Hello guys, welcome to the channel. From today we are starting our core machine learning series. So first understand what is machine learning. Basically, machine learning is a branch of artificial intelligence through which computers learns from the data, and then it make predictions or take decisions on the basis of the data we provided. Okay. So this is what machine learning, and there are three types of machine learning: supervised learning, unsupervised learning, reinforcement learning. We will see all these three learnings one by one, but first we will go for supervised learning. Okay, there are two types of supervised learning: classification and regression. Okay, first understand what is supervised learning. So supervised learning is a type of machine learning where the model learns from the labeled data. Okay, what is the meaning of labeled data? Labeled data means we know the input. Okay, this is our labeled data set. Okay, we know the input and also we know the correct output. Okay, so this is our labeled data set in which we have our inputs also, outputs also. We know the input and output both. Then we will train our model using this label data set. We will train the model here. But first, we will always split our data set into two parts: training data and testing data. On the basis of by training data, we will train our model. We will train our model from the training data, and once my model will be built, then remember, I splitted the data into two parts, training data and testing data. Now, I will test my model through my testing data. Testing data, okay? Now, on the basis of testing data, my model will give predictions. Predictions that this is apple, this is apple, this is orange, and this is how supervised learning works. Okay? So there are two types of supervised learning: regression and classification. Regression for continuous values and classification for categories. Categories means yes, no, true, false, or maybe more than two types of categories like red, blue, green, cat, dog, cow. Okay, these are categories. We will predict through classification, and continuous values for we will predict by regression. Means suppose someone has 25,000 salary, someone has 50,000 salary, we will predict the salary or something like that. Continuous values. Okay. This is what supervised learning means, and there are two types. From next videos, we will learn how we can practically implement these algorithms. These are it: algorithm, regressions algorithms, classification algorithm. Okay. First, we will understand how we can apply these algorithms for our supervised learning for classification and regressions. Okay. Then after supervised learning, we will cover unsupervised learning and then reinforcement learning. Okay. So that's all in this video. From next video, we will cover practically the different algorithms of regression and classification. Okay. Thank you. Hello guys. Welcome to the channel. From today, we are going to start our new topic, that is supervised learning, and our first topic is train test split. Now, what is train test split? Train test split is a technique used in machine learning to divide a dataset into two parts. Training data used to train the model, testing data used to evaluate the model, right? Purpose to check how well your model performs on unseen data. Now, suppose this is my dataset, okay? This is the dataset on which I will work. So this is my column. Okay, this is my column row. And suppose I am counting the total rows. Yeah, 1104. If I don't count the columns, then I have 1103 columns. Okay, now what will I do? Now suppose I am building a machine learning model. Okay, so then what I will do, I will divide my data set into two parts: training data and testing data. Suppose I have converted my dataset into divided my dataset into 80% and 20%. 80% for the training data and 20% for the testing data. Now, from 80% of the dataset, I will train the model, and then when the model gets prepared, then I will check its output through the 20% testing data to check whether it is giving the correct output or not. Okay, so that is the concept of train test split. So why do we need train test split? If you train and test on the same data, the model may memorize the data. Obviously, like suppose you train the model by 100% data set. Now you have to check its output, that it is giving correct or not. If you if you check by the same data set from which you have trained the model, obviously it will give the right answer. Okay, so very high accuracy. Obviously, when it will give all the answers right, then it will give a higher accuracy, but it will be misleading. Okay, so obviously, always convert data set into two parts: training data and test data before building your model. Okay, now suppose basic idea: train, learn patterns, train data set for learning patterns, test data for checking performance of the model. Example: suppose I have 100 data points, means 100 rows. I will I will basically keep my 80 rows for training and 20 rows for testing. Okay, how it works? Shuffle the data set. First, shuffle the data set randomly. Okay, then split it into two parts: training and testing. Train model on training data. Basically, prepare the model by training the model by training data set. And now when basically model gets prepared, then test the model by testing data, then like it is giving correct output or not, right? So I will show you how we can do train test split using Python. For coding purpose, I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So when you will download it, just search here Anaconda prompt. Anaconda prompt. CD. Give your file location. My file location. Control C. Control V. Enter. Write Jupyter Lab. It will navigate the Jupyter Lab into my browser. I will wait for a few seconds. No, I will choose this. I will rename this. Rename first topic. Train test split. Okay. No, I will import some basic required libraries with Pandas. SVM. Now I will load my data set. Data is equal to pt.read slash csv because I have CSV file. I will give you the data set. Copy path. Control T. Check my data is loaded or not by data.head. It will give you first three rows, data.head 3. Yeah, my data gets loaded. Okay, suppose first I will check is there any null value or not in any column. No, I don't have any null value. So perfect. Okay, now first Basically, first divide your columns into two parts. Divide your input columns and output columns. Means this is my output column. Okay, it column depends on these columns. Okay, right. So just divide columns into two parts, input and output columns. Okay. Now suppose x is equal to data dot drop means give the whole data set but drop only one column, that is lat. This is the data set for house price prediction. Okay. So this is the column for house price. Okay. So this is your output column. Means these factors will decide how much value your house, how much price the house could have. Okay. Now, so I will take y. Y is equal to give me the give me the only output column, right? I have taken all the columns, input columns into X. Now I will take output column into Y. Okay. Now I am divided into two parts. Now I will now divide the data set into two parts, training data and testing data using Scikit-learn's train test split. Now how I can do it from sklearn dot model selection import train test split. Okay. Now when I will convert the data set into two parts, training data and test data, then I will always have four, basically four variables, four total, four total type of variables in which data will contain. First, X train and X test. Okay. Then Y train and Y test. Okay. Now I will X train, X test, Y train, Y test is equal to, now I will call my train test split to co- convert, basically divide my data set into two parts, X comma Y, right? Now test size. Test size means suppose what ratio you want to divide your data set. Now I suppose I want to divide my data set into two parts, 75% and 25%. Now 25% means 25% will be your testing data. Okay. So mm, if you want to take 25% of the data set for your testing, then write 0.25. If you want to take 20%, then write 0.20. Okay. Now I will write one more thing. Random variable. Random state. Random state is equal to 42. What it means? Suppose, suppose it divided the data set into two parts, training and testing. It will randomly divide into training and testing. It will not divide like from 0 to 700 rows. It is testing data and rest you have training. No, it will not work like that. It will randomly divide your data set into training data and testing data. Now, suppose I run this line. Okay. Now data gets divided. Okay. Now data gets divided. Then suppose you open the program again. after some time. Then again you basically run this line. Okay. Then if I don't write this random state, it will again change your data set. It will basically again randomly divide your data set into two parts. If you will write random state is equal to 42, then it will be fixed. First time only it will divide your data set into random, then it will keep the data set remaining, it will remain same. Okay, by writing random state is equal to 42. Okay, now suppose I will check x train dot state. Now 827 rules. Okay, now first I will show you data dot set. Okay, from 1103 rows you got 827 for training data. Obviously 14 columns because I have not taken the output column in X. Now it has converted 827 into training data from 1100. Now check X.save. 276 for testing data, right? Same same for Y also. 827 and one column. 276 rows for one column. Okay. Y for output basically. Okay. So it has converted our output column 827 for basically training data set, 276 for testing the data set. Okay. For output column, and for input columns 827 for training, 276 for testing. Okay, this is what the concept of train test split. We will always use train test split before building any machine learning model. Okay, in the next video we will cover linear regression. Okay, that's all in this video. Thank you. Hello guys, welcome to the channel. In today's video we will discuss simple linear regression. Okay, so first understand what is linear regression. Linear regression is a supervised learning algorithm used to predict continuous values. For example, predict house price, predict salary, predict temperature. Okay. So basically it has two types, simple linear regression and multiple linear regression. Okay. We will cover both. In today's video, we will cover simple linear regression. Okay. So what it means? In simple linear regression, we will have one input column and one output column. On the basis of in this data set, on the basis of ours, we are predicting how much scores a student will get. Suppose someone studies for 1.1 hour, he is getting 41 marks, 1.2 is getting 40 marks. So on the basis of that, we will make a prediction model using simple linear regression, and we will check that. Okay, now first understand. Okay, basic idea. Now what this algorithm do? See, suppose this is the graph I have plotted between my independent variable and dependent variable, means input value and output value. Okay, so first see, these are the data points, actual data points. These are my actual data points. These dots are my actual data points. What this algorithm do is it will draw a prediction line. Okay, and it will try to basically draw that prediction line as close as possible to the actual data points, means these values. Okay, it will always try to draw a prediction line as close as possible to its actual values. Okay, so this is how this algorithm works. We will check that by working on this practically for this data set. Okay, so I will show you how we can do it. For coding purpose, I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So once you will download it, just search Anaconda prompt, write cd, give your file location, control V, press enter, write Jupyter Lab, press enter. It will navigate Jupyter Live into my browser. I will wait for a few seconds. I will choose this. Suppose I will rename. Suppose I will give simple linear regression. First, I will import some required libraries. Suppose NumPy, NP, import Pandas, SVD, import matplotlib.pyplot as PLT, import cborn as SNS. Okay. Now I will load my data set. Okay. Data is equal to pd dot read slash csv because this is my CSV file. By the way, I will give you the data set. Right click, copy path, control V. Now check my data is loaded or not by checking its first three rows. So yeah, my data gets loaded and these are its first three rows. First, I will check is there any null value in my data set. No, there is no null value. So it is perfect for operating. First, first I will show you by drawing a graph. I will show you its actual data points. Okay. So first plt dot figure. I will take some figure size. Fig size is equal to 5. I will plot a scatter plot. I will take my x for hours, y for scores, and data will be my data because in my data variable I have loaded my data set. Okay. Now plt dot show. Okay. These are my actual data points. Okay. These are my actual data points. So as you can see, I can see here, I have some outliers also in my data set. So how to handle outliers? I have already made a video on this. So in this video, we will not handle outliers. We will just basically understand simple linear regression algorithm, how it works by building a model. Now, now in previous video, I have covered in- before making any model, machine learning model, always we will divide my data set into training and testing. Before that, I will divide my data set into input and output. Okay. So I will take my input in X data. Our column is my input column. Control C, and in Y I will take my output column. So score is my output column. I will take that in my Y variable. So data gets divided into input and output. Now I have to divide my data set into training and testing data. Okay. So I will first import from sklearn model selection, import train test split. Okay. Now I will take my all four variables to divide my data set into testing data set, train and test data set. Y train, Y test is equal to. Now I will call train test split to divide my data set for which variables X and Y I have taken. Now suppose I want to divide my data set into 75 is to 25 ratio, means 75% for the training, 25% for the testing. So how much we are taking our testing data? 25%. So I will write 0.25 and I will give random state is equal to 42. I already discussed its theoretical part of random state in my previous video. You can check that. Okay. Now set plus enter. So X train for training data for hours. X test means testing data for hours. Y train means testing data for scores, and Y test means testing data for score. Okay. So this is how I have divided my data set into 75 is to 25 ratio. Okay. Now I will make my model. From first I will import linear regression sklearn dot model, sorry, linear model, import linear regression. Okay. Now suppose I will make a object to call linear regression. Okay. Now I will fit my training data into it. Y train. Okay. I'm giving the training data set for the model. Okay. I have given my training data for linear regression for the model. I have trained the model. Okay. Now suppose I will check my accuracy. Okay. Suppose I will check my accuracy for the model. So this is how we can check the accuracy of the model. It is showing 50% is my accuracy. So it is very, very low accuracy showing for my model. This is because we have not removed the outliers. Okay. In my previous videos, I have already covered how to handle outliers. So I am not covering this uh, basically I'm not handling outliers in this video. You can check that video. So my model gets trained and I got my accuracy of the model. Okay, because I have not removed outliers. I have not removed basically outliers, so it is giving me very low accuracy. Okay, so no worries. Now, suppose I will try to predict a value. Suppose, suppose I will take a value 1.1. See, for 1.1 it is 41. Okay, now I will check 1.1. Okay, I am not given the parenthesis. Okay, so this is a warning. You can ignore. So it has given 38, but you can see it was 41. So it predicted 38. Means suppose a student who studies for 1.1 can get the score of 38 if the model predicted. Okay, so this is how it gives prediction. Now I will make a new variable. So y predict is equal to lr dot predict. I am predicting my testing data set. Okay, x test. Okay, basically we are using train model to predict output values for unseen data, means training testing data. Okay, now step plus enter. Now I will plot a graph to show you how it draws a prediction line. Okay, so these are my actual data points. These are my actual data points. Now I will plot a graph to show you how it draws a prediction line. Okay, between the actual data points. Okay, now suppose I will give some bigger size first. Now I will plot again a scatter plot. I will take exactly same. Okay, now I'm give I'm giving a prediction line. Okay, we dot plot data. I will take r's column, comma y predict. This is which I have predicted for testing data set. Okay, y predict. Suppose I will give a color to the prediction line red. Okay, I'm giving my prediction line as red. Now, suppose I will give some PHP.legend for giving a title. Sorry, to basically recognize the data points and the prediction line. Okay, prediction line. Okay, now I will do plt dot show. Dimension, but I say 60 then 15. Okay, Suppose I will not keep this. Okay, now see, see, this gave me a prediction line. Okay, this gave me a prediction line. So this is how it predicts the between the actual data points. Okay, so as I have shown already in my notes, so it tries to keep this prediction line as close as possible to its actual data points. Okay, so exactly here, yeah, this gave me a prediction line. It tried to keep all the data points as close as possible to its the prediction line. Okay, so this is how it predicts the value. Okay, so that's all in this video. In the next video, we will cover multiple linear regression. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss multiple linear regression. So what is multiple linear regression? Multiple linear regression is an extension of linear regression where instead of one independent variable, means instead of one input column, we will have multiple features, means multiple input columns to predict the target y, means to predict the output column. So we saw in the previous video where I performed simple linear regression where I had one input column and one output column. Output column will be one in every case, but I had also only one input column, right? So see, on this data set today we will perform multiple linear regression. Okay, so these are the two input columns. Okay, these are the two input columns. On the basis of these two input columns, we are predicting our output column, that is salary, total experience and total certifications. By total experience and total certifications, I am predicting the employee's salary. Okay, so you can see here we have multiple input columns. We can have four, five, six input columns also, but in this case, I am taking only two input columns. Okay, for performing multiple linear regression, right? So we can see by plotting a 3D graph for multiple linear regression. So you can see here x1, x2, and y. X1 and x2 are the two input features. Okay, input columns. Suppose in this case, total experience will be my x1, certifications will be my x2. Okay, and y will be my output column. In this case, I have salary column as y. This is my output column y. And every data point is a salary. Every data point here is a salary on the basis of total experience and total certifications. I have explained it in this notes by taking of example of house price prediction. Suppose X1 has a feature size and X2 feature has a second feature which is bedrooms. And on Y, it's my output. What is my house price? And every data point is my house price with these two input features, right? So on the same way, we have here two input columns. On the basis of two input columns, this and this, I am predicting my output column. So how we can basically build a machine learning model using this data set using multiple linearities. Okay, so I will show you. So for basically coding purpose, we will use Jupyter Lab. Please download Anaconda Navigator to to perform to build machine learning models in Jupyter Lab. So in my system, it is already downloaded. So just search here after downloading Anaconda Navigator, Anaconda prompt. Okay, Anaconda prompt. Write CD. Give your file location here. Give your file location, control V, press enter, write Jupyter Lab, again press enter. It will navigate my Jupyter Lab into my browser. We will wait for a few seconds. I will choose this. I will rename this. I will rename this multiple. Okay. Now I will import some required libraries. Okay. Import matplotlib dot pyplot as plt. Import cbond as sns. Okay. Now I will load my data set. Okay. Suppose I am taking a variable data to load my data set. pt.load slash csv as because I have csv file. Right click, copy path, control V. Now check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and here are its first three rows. Now I will check is there any null value in my data set. We can check that. Okay, there is no null value in my data set. Okay, so this is fine. Now, now I will first show you by plotting a heat map that data, I'm taking data as data's correlation, okay, and not is equal to true, plt.show. Now you can see total experience column is nearly 1. So it is very important column for my output column salary, total experience. Certifications. Certifications is not too much beneficial for my salary column, but yeah, I will take certifications also because I have to show you the multiple linear regression. So it should have more than one input columns in it. So now first I will divide my data set into X and Y, right? X and Y. And in X, I will take my all input columns, which are total experience and certifications. And in my Y column, Y variable, I will take my salary column as output column. Okay. X is equal to, I will use ilog. I will use ilog minus 1. So what we are doing here? So I'm saying in my X variable, give me the whole data set of all, give me all rows. This means all rows. And this means give me all columns also, but minus one. Minus one means leave the last column. Last column is my output column. So leave this column and give me all in all columns and all rows. Okay. So this is what the meaning of X is equal to data.ilog is. Now I got my all input columns in X. Now I will take in Y my output column. Okay, what is my output column? Salary. Okay, now now I will split the data set into training data and testing data. Suppose I will split my data set into 80% for training data and 20% for the testing data, right? How we can do that? From sklearn dot model selection, import, train, test, split. Okay, Shift plus enter. Now I'll give all four variables x train, x test, y train, and y test. Okay, is equal to, I will call my train train test split. Okay, now what are my two variables in for input and output column, x and y? Now I have to convert my data set into 80% training and 20% for testing. So how much we are taking for testing? We are taking 20%. So I will write test size is equal to 0.2. Okay, I have already discussed that train test split in my previous video. In our previous video. Okay, so random state is equal to 42. Okay, now my data gets splitted. Now I will build my machine learning model for this data set. Okay. Now from sklearn dot linear model import linear regression. Okay. 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 This is the spelling mistake. Sorry for that. Okay. Now I will give an object to call my linear regression. Suppose I will take LR is equal to linear. I have made an object. Okay. Now I will fit my X test and Y test. Okay. Sorry, X train and Y train for my linear regression model. Okay. I will fit that. How we can fit that? LR dot fit. I am training the model by X train and Y train. Okay. X train means training data of these two input columns, and Y train means training data of this output column. Okay. So I am training the model by giving X train and Y train. Okay. So it's get fitted. Okay. My model get trained. Okay. Now I will check the accuracy of my model. How much accuracy I am getting for my model. LR dot score X test comma Y test. Right. Plus enter. So we are getting a accuracy of nearly 90%. Just multiply by 100. Yeah, we are getting accuracy of almost 90%, which is a very good accuracy, right? We can improve my accuracy also. But yeah, this is also a good accuracy for my model. Okay. Now we will check by predicting a value. Okay. Suppose I will take this input 7 and 1 for predicting salary. Okay. So LR dot predict. What are my values? 7 and 1. I will give 7 and 1 as my input. Okay. Now see here. It gave me 79,139. Okay. So here it was 77,318 was my actual and it gave me 79,100. So it is nearly close. Okay, so it is giving not perfectly, but yeah, it is quite accurate, right? Because also it has 90% accuracy. So this is how we can perform multiple linear regression. Okay, so that's all in this video. In the next video, we will discuss polynomial regression. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss polynomial regression. Okay, so what is polynomial regression? Polynomial regression is an extension of linear regression where we model non-linear relationships between input and output. Instead of fitting a straight line, we fit a curve. Now, what it means? In our previous video, we saw how we can use multiple linear regression and simple linear regression for basically for that kind of data sets in which our independent variable and dependent variable is following linearity. Okay, so when we will use polynomial regression, okay, when we will use polynomial regression, when our input column and output column will not follow linearity. What it means, suppose, see this graph. Suppose this graph is of input and output column. So here you can see it is making a curve, not a straight line, right? In these kind of scenarios, we will use polynomial regression. Okay. So what first we will see, why do we need it? In real world data? Relationships are often not linear, which I explained. Suppose an example, salary versus experience. Initial growth slow, then fast, then stable. So this will not follow linearity. Then we can perform polynomial regression. Temperature versus energy consumption, growth patterns, right? So in these cases, we will use polynomial regression in which input column and output column will not follow linearity. Okay, this is making curve. So we will use polynomial regression. Now, how it works. Suppose start with feature X. Suppose this is my data set, okay, and this is my input column and output column, okay. And now I have this feature X, okay, and suppose this data set will this input and output column will not follow linearity, okay. Suppose I have this column X, which is an input column, okay. Now we will start this with x, our x feature, which is our input column. Now in when we will fit polynomial regression in our algorithm, then we will have to choose a degree is equal to 2, 3, 4, 5, anything, any value, okay, up to degree n. So what it will do? Suppose I chose degree is equal to 2. What degree is equal to 2? What will it do? It will create a new feature. Suppose I choose degree is equal to 2 while fitting polynomial regression into my model, into my x feature, means in my input column. Then it will create a new feature, x square. It will hold all the squares of the value. Suppose I chose degree is equal to 2 to fit this x column. Okay. So it will create a new feature and all the values in x square will be its these values squares. Okay. Now suppose I choose x is equal to 3, then it will create two new features. What it means? Suppose I choose degree is equal to 3, it will basically increase two features. One will x square and another one will x cube. In x square, all the values will hold squares of these values, and x cube, there will be all cube values of these values. Okay, this is how polynomial regression works. Okay, and then we apply linear regression on the new features. Okay, to create a model. Now we will see this using Python practically. For Python, I will use JupyterLab. For using JupyterLab, please download Anaconda Navigator. Once it will downloaded in your system, just search Anaconda from right CD. Give your file location. This is my file location. Press enter. Write JupyterLab. Press enter. It will open JupyterLab into my browser. I will choose this. I will choose this. I will rename this polynomial regression. I will import my required libraries. Okay. Plot as PLT, import cbond as essence. Okay. Now I will load my data set. Okay. Data is equal to pd dot read slash csv because I have CSV file. This is my file. I will right click copy path, control V. Now I will check my data is loaded or not. Okay. So yeah, my data gets loaded and these are my first three rows. Okay. Now, first I will plot a graph to show you that this data set, this input and output column is not following linearity. Okay. Suppose plt dot scatter data. I will take my first column, control V. I will take my second column. Now, now plt dot show. Now you can see this is making a curve like a curve. Okay, this is not a linear line. This is not a linear line. Okay, so it is not following linearity and it is basically making a curve. So we will have to apply polynomial regression before making our model through linear regression. Okay, so first First, I will divide my dataset into input and output. So we all know this is my input column and this is my output column. Okay. Suppose x is equal to data. I will take this input column into my x variable. Now in y variable, I will take output column. Okay. So I have separated input and output columns as x and y. Now, now I will import my polynomial regression sklearn dot pre-processing import polynomial features. polynomial features. Okay, shift plus enter. Now, suppose I will make a object to call my polynomial features. Okay, now we will have to give degree. Suppose I will give degree is equal to 3. What will degree is equal to 3 do? It will give two new features to my input column. Two new features, x square and x cube. X square, in x square feature, all the values will be these values squared in, and in second column x cube, all the cube values of these values will occur. Okay, so suppose I will take degree is equal to 2, then it will create a single new feature for my x feature, which will be its squares. Okay, so I have taken suppose degree is equal to 3. Now I will fit my x column because that is my input column x. Okay. Now I will transform my x dot transform. Okay. Now my input column, I have taken my input column into x variable. By degree is equal to 3, I got two new features, means two new columns for my x column, means input columns, x square and x cube. In x square, there will be my squares of these values will occur, and in x cube, cubes of these values will occur. Okay, so I got my two new features, and total I have now three features. Okay, three input columns now I have by using polynomial features, right? Now, now I will now I will build the model using linear regression. Okay, from scalar dot. First, I will basically divide the dataset into training dataset and testing dataset. Okay, into suppose 80% and 20%. 80% for my training and 20% for my training. So first, I will import train test split model selection, import train test split. Right now, now I will take my all four variables x train, x test, y train, and y test, and I will fit by train test split. I will call basically train test split. I have taken x and y column. Now I want 20% of the data set will be my testing data set. So I will give test size is equal to 0.2. Now random state is equal to 42. Okay. This is how we divide the dataset into training dataset and testing dataset. Now, my data gets divided into training dataset and testing dataset. Okay, so I have already covered train test split in my video. You can check the video. Okay, now I will build my model from scalar dot linear model import linear regression linear regression. Okay, suppose I will take an object. I will take an object to call linear regression. Okay. Now, now I will fit my X train and Y train into my linear regression for basically training the model by my training data set, right? X train and Y train means training data set of temperature means the input column, and the training data set for my Y column means output column. Okay. LR dot fit X train and Y train. Okay. I'm training my model by my data set of training data set. Okay. It My model gets trained. Now I will check my accuracy of my model. Okay. X test. I will check my accuracy by testing data set into 100. Now, I got an accuracy of 84%. That is not so much good accuracy, but although we got the understanding of polynomial regression and then how to fit it by linear regression. Okay, so we got to know the concept of polynomial regression, right? Now, now I will show you a graph through which I will describe how it tries to basically draw a curve line to best fit the predicted data. Okay, to actual data, right? TLT dot scatter. I will take this. I have already plotted graph. Okay, now I will give a red line. I will again take this. Okay, now suppose I will make a new variable first. Predict. Okay, predict is equal to LR dot predict my X column. Okay, okay. I make this PRD and I will give color as red. I will give my line as color red. Okay. Now, now we will show reality dot. Okay. Okay. I forget this. Okay. Now see. So first we had a data set in which input columns and output columns were not following linearity. It was making a curve. So it tries to predict by making a curve line, making a curve line to predict the predict the data. It tried to it tried to be as close as possible to actual data point. These blue data points are actual data points, and this is a prediction line. So that's how polynomial regression works. Okay, so this is how we use polynomial regression. Okay, for non-linear data. Okay, non-linear data. Okay. So that's all in this video. In the next video, we will see regularization techniques. So thank you. Hello guys, welcome to the channel. Today we will discuss regularization techniques in linear models. Okay. So first, what is regularization? Regularization is a technique used to reduce overfitting in machine learning models. What is overfitting? Overfitting means modern learned noise plus patterns perform poorly on new data. What it means? Always remember, a good model learns only the real pattern. An overfitted model learns everything, including noisy data also. So we just need to train the model on the real pattern. Okay, not on noisy data, means everything. And overfitting means suppose I have a data set and of how many hours you study and how much marks you get. Suppose I have data set, someone studies for 1 hour and he got 40 marks. Someone studied for 2 hours, got 50 marks. And one value came, someone studied 1.1 hours and he got 95 marks. So that is right data. But in our case, that is an case of overfitting. We can't train our model on that particular data. So this is what overfitting and what regularization do adds a penalty to the model to keep it simple. Simple. It will add a penalty to the features so that our model will be simple and will be only gets trained on basically the real patterns, not noisy data. Okay. So why regularization is needed? Model becomes too complex. Okay. Suppose you have a case of overfitting and underfitting both in your data set. Some not necessary features or columns in your data set. Okay. Coefficients become very large. Model memorize instead of learning. But every model should learn, not memorize the data, right? So so how we can perform regularization? We have two methods. Okay, for linear model. Okay, for linear model. First, L1 regularization means Lasso regression. Okay, it adds absolute values of coefficient and can make some coefficients exactly zero. What it means? Suppose I have this data set. Okay, and this is my output column. Okay, on the basis of this till H column, these are my input column. On the basis of this input column, this output column is changing, right? So, suppose I have this data set. Okay, I have this column. Okay, and it is not adding any like major changes to my this output column. Or this is in simple words. See, suppose this column is not necessary for me. Okay, it is just increasing the complexity of my model or of my data. Okay. So what lasso regression do? It will make all the coefficients equal to zero. It will make this column as zero. Okay. So so basically by this method, model automatically does feature selection. And what is feature selection? How to do feature selection? I have already discussed. You can check my video. Okay. Okay. It basically removes unnecessary features. What this method actually do? Removes basically unnecessary features. Like suppose this is my unnecessary feature, it will remove them. Okay. So this method we understood what it do, when to use when you have many features, okay, and when you want to remove useless features, right? Now, second, L2 regularization, with regression, okay, it adds a square of coefficients, strings value, but never makes them zero. it makes the coefficient 0, but it never makes the coefficient 0. Remember that. Okay. It adds square of coefficient. What it means? Keep all features but reduces their impact. When to use? When all features are important, means all the columns of your data is important. You have to take all the data, then you can apply this method. And okay, suppose suppose this is my data. Okay, this is my column, input column. Okay, so you can see weight of this column is too much. Okay, too much weight of this column. When we will apply this method ridge regression, it will reduce the weight of this input column. It will not make them zero because this is the necessary column for me. Okay, so it will reduce the weight of the column. Okay, now we will see how we can do it practically. Okay, so first I will copy my file location. I will search Anaconda prompt. Cd, okay, enter, write Jupyter Lab. It will open the Jupyter Lab into my browser. I will wait for a few seconds. Now I will choose this. I will rename this. Regularization techniques. Okay. Now, first I will import some required libraries. Import NumPy as NP. Import Pandas as PD. We are not importing matplotlib and Sequence because I have not to uh, basically I have not to draw a graph, so I will not import that. Now I will load my data set. Data is equal to pd.read slash CSV because I have CSV file. For every video, I'm giving the data set. So this is my data set. Right click, copy path, control D. Now I will check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and these are my first three rows. Now, first I will check is there any null value before performing any operation on it. Yeah, I have 207 null values in total bedrooms column, right? So I will fill that first data dot fill and sorry, I have to fill this dot fill and suppose I will fill by the total bedrooms median. Okay, how we can do that? I will again take dot call fill total bedrooms null value dot fill and by its median. Okay, in place equal to true. Okay, this is an warning. This is not an error. Okay, now suppose I will I will draw a heat map. Okay, I will plot a heat map. Okay, put matplotlib dot pyplot splt import cborn as SMS. Now, now I will show you by plotting a heat map to show you how my features are affecting my output column or not. Heat map. I will take data as my data's correlation, not is equal to true. PHP dot show. Now, see longitude minus 0.046. So that is not affecting my data, right? So this is a useless feature for me. Latitude also same. House, median, age. This is affecting my output column a little bit. This is also affecting my output column a little bit. It is 0.049, I think. So this is also not that much useful for me. This feature population 0.025 minus 0.025. So it is a useless column for me. Households again, that is not a good feature for me. And median income, yeah, this is 0.61. Yeah, this is an important column for me because it is nearly 1. Okay, so now now I will first divide my data set into two parts, input and output. This is my input column and these are my this is my output column and these are my input columns, right? I will take all the input columns into my X. Suppose data dot drop. I will drop this only output column. I will enter. I will write x is equal to 1 and y is equal to data. I will take the output column. Sorry, it is already copied. Okay. So I have divided my data set into input and output. Now I will do basically feature scaling by standardization. I have already discussed in detail how to perform feature scaling using standardization. You can check the video. Okay, first from scalar dot model selection import standard scalar. Okay, scalar. Okay, okay. For that, it's processing. Okay, now now suppose I will create an object for calling standard scalar. Okay, Now I have to fit my standard scalar for my x because all the input values are my x. So I will fit my x to a standard scalar. Okay, it gets fitted. Now, now I will import this into a data frame. See the transform x columns is equal to x x dot columns, right? Now, now I will divide my data set into training data and testing data. Now suppose I will divide my data set into 80% for training data and 20% for testing data. I will all these things train test split standard scalar scaling or all these things I've already discussed. You can check my previous videos. Okay, I will check. I will give all the four variables y train y test is equal to I will sorry, first have to I will have to import train test split from SVM dot model selection import train test split. Now I will call my train test split. I've taken x and y variables. So I will give that. Now test size means how much we need testing data 20%. So I will write test size equal to 0.2 and I will give random state is equal to 42. Okay. Now my data gets divided into training data and testing data also. Okay. Now, now I will first make a model. Then I will apply these two methods, ridge regression and lasso regression. Okay. So first I will import scalar dot linear model. Import first I will import linear regression. Lasso and ridge. Okay. I will import all this. Okay. Now first I will make a make an object to call my linear regression. Okay. Now now I will train my model. How I can train lr dot fit my training data. By training data, I will train the model. So it gets fitted. Now I will check my lr dot score. Okay. Y test into 100. So yeah, this model is giving accuracy of 61, which is very low accuracy, right? So this means we need to apply these methods, okay, for controlling our model to remove. basically not unnecessary columns, or we need to remove the weights of the columns, right? Suppose I will give the matlab, uh, I mean, I will check the coefficient means uh, it will give the weight of each feature in the model. Each feature means each column in the model. Okay, it will give the weights of each feature in the model. So yeah, it gave me it gave me the weights of each feature. Okay, so this is how you can see the weights of each column of my input column, right? So now I will show you. First, we will calculate how wrong is my model. Means mean absolute error, uh, mean squared error. Okay. So first, I have to import from sklearn dot metrics import mean absolute error and mean squared error. Okay. I have imported this. Now, first, I will calculate mean squared error. Means how much is the difference between my predicted value and the actual value. And I will do means mean squared error means square that value. Give basically suppose I got 2, then just square 2 means I will get 4. Okay, so mean squared error, just the difference between my actual value and the predicted value. Okay, mean squared error. Sorry, y test L, and I will take LR dot predict X test, right? I will see my MSC. So yeah, I got my mean squared error. It is too much high. Now, now I will calculate mean absolute error. Okay, average of absolute errors. Okay, average of absolute errors. Let's take MA is equal to mean absolute error. Same I will with this. Now I will see my MA. So yeah, I got my mean absolute errors. Mean average of absolute errors. Okay. Now I will calculate RMSC is equal to first I will have to import NumPy. Yeah, I have already imported NumPy. Okay. RMSC is equal to NP dot square root means our actual error. Okay. Actual errors mean. Okay. Means we have squared for MSC the mean of the squared error. I have squared the error, right? Basically, the difference between my predicted value and the actual value. I received that for whole columns, and then I received my mean, and then I squared this. Okay, now I will calculate its actual error. Error mean. Okay, actual error mean. So actual error mean is this. Okay, without doing a square of this. Okay, now. Now we will see how to apply these regularization methods for my linear model. Okay. Now first is my lasso regression, right? I will first see lasso regression first. LA, let's take LA, call lasso alpha is equal to 0.5. What is alpha 0.5 means? Means uh, applied moderate penalty to the coefficients. Okay, coefficients mean the values of my feature. Okay, moderate means not too much low, not too much high. Apply the penalty for my coefficient for the feature. Okay, moderate penalty I'm applying. Okay, now now I will just do LA dot fit. What I will fit X train and Y train, right? Okay, yeah, it gets fitted. Okay, so we saw how to use lasso, right? And now we will see ridge regression. Only difference is alpha we have to choose. Okay. In this, suppose I have to do strong regularization. Okay. So I will choose alpha is equal to, let's say, 10. Okay. Sorry. Again, I will suppose take Ri, and here I will write ridge. Okay. Now, now I will fit my X train and Y train into ridge. Sorry, Y train. Okay. It gets fitted. So this is how we ap- we perform lasso and ridge for regularization. Okay, so that's all in this video. In from the next video, we will see logistic regression. Okay, thank you. Hello guys, welcome to the channel. From today, we are starting our classification algorithms, and our first algorithm is logistic regression. Okay, so, what is logistic regression or what is classification? You can understand by this. Okay, logistic regression is a supervised machine learning algorithm used for classification problems. So, understand what is classification problem. Basically, it predicts categories or classes instead of continuous value. We saw in our regression algorithms like linear regression, multiple linear regression, we predicted continuous values like 5, 10, 20, like this. Okay. Now we will predict categories or classes. What it means. Suppose example, spam or not spam, pass or fail, disease or no disease, yes or no, customer will buy or not buy. Okay, these are examples of categories which we will predict by classification algorithms. Okay, so the output is usually 0 for no and 1 for yes, means false and true. Okay, now you can understand logistic regression through this graph. Now we have 1 and 0 predictions, no, yes, or false or true. Means suppose this is spam, means true. This is not spam, false. Okay, pass, true, fail, 0. Okay, so it will always predict from 0 to 1. Okay, so we saw in our uh, basically linear regressions models, we saw linear graphs or non-linear graphs. In this type of algorithm, we will always see it will basically draw as curve as curve. Okay, it will draw as curve to predict the values, predict the basically categories 0 or 1. Okay, so we will perform our logistic regression on this data set. This is input column and this is output column. Means suppose I am 19 years old. It has a chance to that something I will not purchase. Someone of age 35 will not purchase. Someone of age 32 will purchase. This is that kind of data set. Okay. So I will show you how we can do it practically. Okay. Now, first I will import some required libraries. Import NumPy as NP, import Pandas as PD, import matplotlib.pyplot as PLT, import cbon as SNS. Now I will load the data set. Suppose data is equal to pd dot read slash csv, because I have CSV file. Suppose this is my data set. I will right click, copy path, control V. Now I will check my data is loaded or not by checking its first three rows. So yeah, my data gets loaded and this is my first three rows. Okay. Now I will first plot a graph to show you how the graph of classification problems looks like. Okay. PLT dot figure fixed size. I will take some size for my graph, 4 3 suppose. Now I will plot a scatter plot. I will plot a scatter plot. Suppose I will take x is equal to age, my age column, and y for purchased column. Okay, purchased, purchased. Okay, and data. What is my data? Data is my data because in data variable I have stored the data, right? So I will write data. Now plt dot show. So for 1 and for 0, this is how it looks like. Okay, 0 1, sorry, 1 and 0. Okay, means purchased, no, they will not purchase for 0, and yes, they will purchase for 1. Okay, now first I will basically divide my data set into input column and output columns. Age is my input column and purchase is my output column. Suppose x is equal to, I have taken my input column. What is my input column? Age. And for y, I will take my output column. Okay. Okay. Now I have taken input column and output column separately. Okay. Now I will I will divide the data set into training data set and testing data set. Training for training my model and testing for testing the model after building the model. Right. So first I will import train test split from sklearn dot model selection import train test split, right? Now I will take my all four variables x train, x test, y train, and y test is equal to, I will call my train test split. Okay, so which columns, which variables I'm splitting, x and y. So what in what ratio I want to divide my data set? I want my data set into 20% for the testing data and 80% for the training data. So I'm taking 20% as my testing data. So I will write test size equal to 0.2. Now I will write random state is equal to 42. Okay. These things I have already discussed in detail. Now my data gets divided into my into my training data and testing data. Okay. Now I will build my model from sklearn dot linear model import logistic regression. Okay. Logistic regression. Now suppose I will make an object to call logistic regression. Now I will fit my lo- uh, training data set into my model x train and y train, right? Now it gets fitted. Okay, it trained my model. Now I will check my accuracy of the model. Okay, lr dot score x test comma y test into 100. So yeah, I'm basically getting 91% accuracy, which is quite high accuracy, which is good. Means our model is good. Okay. Suppose I will check by predicting a value. Suppose I will check 19. Okay. I'm taking 19. Okay. So let's see what it predicts. Sorry, I forgot to put parenthesis. Yeah. So yeah, it gave me 0. Okay. So see here. It was 0 here also. Okay. And it predicted also 0. So yeah, my model is working good. Now I will show you how it predicts, how it draws a line for predicting values for 0 and 1. Okay, I will I will show you a prediction line on this. Okay, I will show you a prediction line on this graph. Okay, so suppose I will take first figure size. Figure size is equal to 4 3. I'm taking. I'm making a small graph. SNS dot scatter plot. Suppose I will take age in X and Y for LR dot predict X, LR dot predict X, and I will take data is equal to data, because in data variable I have data set. Suppose I will give some color of my prediction line as red. Okay, I'm giving red. Okay, now plt dot show. Okay. So okay, first give you I will plot this also. Purchased also. I will plot purchased also first, and I will give here line plot. Line plot. Okay, purchase. Okay, sorry. Yeah. So this is how I will not take color in this. I will use default color blue. So yeah, now you can see how it predicted the values, how it predicted the output as user will purchase or not, 0 and 1. How this it makes, how it makes this prediction line. So this is how logistic regression works. Okay, that's all in this video. In the next video, we will see binary classification, multi-class classification. Okay, so thank you. Hello guys, welcome to the channel. Today we will discuss binary classification. So what is binary classification? Binary classification means there are only two possible outputs or classes. What it means? Suppose I have some problems. Spam email detection. There are only two possible outputs here. Email is spam or email is not spam. Disease prediction means patient is suffering from that disease or patient is not suffering from disease. Customer tune. Customer will stay or customer will leave. Loan approval. Loan will be approved or loan will be rejected. So as you can see, there are only two outputs here, only two categories here. So this comes in binary classification where we will have only two type of outputs or two type of categories. Okay. So what is the goal of binary classification? The goal of binary classification. Basically, in this model learns patterns from the data, which will we will give the training data to basically build the model. It will learns the patterns from that training data and then predicts which of the two classes the new data belongs to, means the testing data. When we will test our model with new data, then it will predict from which class it belongs to. Okay. For example, input email text. It will predict email is spam or not spam, right? So this is my data set on which I will apply my classification algorithm. As you can see, this is my output column. You can see only two categories here, 0 and 1. So as you can see, what this dataset means from from the CGP of a student and academic performance of a student, we are predicting the student will get placement or not. That's what we are predicting, right? So here there are only two chances. A student will get placed or a student will not get placed. Okay. So how we can how we can predict that using Python. Okay, we will do this in practical way. Now, first I will import some required libraries. std. Okay. Now I will load my data set in data variable pd.read slash csv. Now I will give the path of my file, my CSV file, right click, copy path, control V. Now I will check my data is loaded or not by checking first three rows, data.head 3. Yeah, my data gets loaded and these are my first three rows of the data. Now, first I will basically divide the data set into input and output. So placement is my output column and these are my input columns, right? So in X variable, I will store my input columns, input column rows, and in Y, I will take placement, which is my output column, right? Now, data, I will use ilog. I'm saying, give me the all rows of the data, give me all the columns also, but don't give me the last column, -1. Don't give me the last column because it is output column, okay? For Y, I will simply go for the data and take this column, control C, control V. Okay, so we will get all the input columns into X and output columns into Y. Now my data gets divided into input and output. Now I have to divide my data set into training data set and testing data set randomly. Okay, now so I will import train test split, go to model selection, import train train test split. Now, now I will take my all four variables x train, x test, y train, y test is equal to, I will call my train test split. These are the things I have already covered in detail. You can check my previous videos, x and y, which which variables or which columns. For which columns we are dividing the dataset into train test for x and y, because in x and y I have stored my input and output column. Now I will take test size, sorry, test size is equal to, suppose I want to take 20% of the dataset as my testing dataset. So I will write 0.2 and random state is equal to 42. Okay, so my data gets divided, right, into training, into 80% for the training data and 20% for the testing data randomly, not sequence wise, randomly it gets divided. Okay, now I will import my logistic regression because it is a problem of classification. Scikit-learn dot linear model, import logistic regression. Okay, now I will make an object to call logistic regression. Suppose LR is my have given for calling my logistic regression. Now, I will fit my training data set into the model logistic regression. LR dot fit logistic, sorry, X train, comma Y train, right? Now it gets treated, right? Suppose means my model gets trained from my training data, right? Now, now suppose I will check accuracy of my model. I will check by giving X test and Y test into 100. Now we got 83% accuracy, which is not that much good accuracy. We will see what are the operations to basically make accuracy better in upcoming videos. But now you can see how we can build a model for binary classification. Now suppose I will predict a value. LR.predict. I will predict, suppose I will give 6.28 and 8. Okay. 6.28 and 8 values. Okay. 6.28 and 8. So we got 0. And here it is also 0. Okay. So we got the right value. So this is how we build model for binary classification. Okay. So that's all in this video. In the next video, we will see multi-class classification, in which we will have multiple classes, not only two classes, or not. We will not have only two categories. We will have multiple categories. Okay. So we will see in the next video. Okay. Thank you. Hello guys, welcome to the channel. Today we will discuss multi-class classification. So what is multi-class classification? Multi-class classification is a type of classification where target or output has more than two classes or categories. Okay, what it means? We saw in our previous video, in binary classification, have we always have two categories in our output. Okay, but in multi-class classification, we will have more than two categories or classes in our output. Suppose I have some problems like animal detection. So I have these classes in my output: cat, dog, horse. In exam grade prediction, I have A, B, C, D, more than two. Flower prediction for iris dataset, we have three categories, right? So basically, in multi-class classification, we will always have more than two categories, right? So you can understand the basic difference between binary classification and multi-class classification by this graph. In binary classification, there are only two classes, and in my multi-class classification, there are multiple classes, more than two classes, right? Now, now when we use logistic regression algorithm for multi-class classification, we can basically logistic regression can apply by logistic regression we can apply a total three approaches for our multi-class classification problem. Okay, first one is multinomial method, one versus rest, OBR method, and direct method. Direct method generally, which already we saw how to like apply logistic regression directly. Okay, so first one, what first method do? Multinomial method. Multinomial method basically it all basically it handles all classes at the same time. All the classes. Suppose I have three classes, total three type of categories in my output column. It will basically treat all the classes at the same time. Okay, instead of creating new model for all classes. Okay, class one, class two, class three simultaneously. Okay. Now, suppose these are my classes in my iris dataset. I will show you the dataset. On this dataset, we will perform our logistic regression algorithm. This is the type of multi-class classification because see, Here we are three categories in our output column, and these are its input columns. Four input columns and one output column, right? So we will apply on this, and this has three categories. So it comes under multi-class classification, right? So what it does, it will directly calculate probabilities for all three classes together. Suppose I got 90% probability for Satosa flower, and it will be higher than other two. Then our prediction will be Satosa because it has higher probability, right? So this is how multinomial method works. First, understand by theory. I will explain it by doing practically, but first understand it by theory. Okay. Second one is one versus rest, OVR method. The name itself suggesting OVR, one versus rest, means one class versus all remaining classes. For example, suppose I have three classes. It will create three different models, right? Three different models because I have three classes. If I will have four classes, then it will create four models. So first model will Satosa versus other, second class versus other, model three, third class versus other two classes. Right? This is how it works. OVR method. Okay, one versus rest method. Okay. The name itself suggesting what it does. Okay. Direct method basically just apply logistic regression to you for your training data and test the model. Okay. So we will see how we can do it using Python. Okay. So first, look at the data set. On this data set, we will apply my logistic regression algorithm for all three approaches. And I have already explained why it comes under multi-class classification because it has three categories. Output column has three categories, more than two categories. Okay, so I will do it of its practical part. First, I will import some required libraries. Import pandas as 3D, import matplotlib dot pyplot as plt, import cborn as SNS. Okay, now I will load my data set. Data is equal to pd.read slash csv because I have CSV file. If you have Excel file, then you can write Excel. By the way, I will give you the data set. Copy path, control V. Now write. Check its first three rows. My data is loaded or not. Yeah, it is taking some time. Yeah, my data gets loaded and these are its first three rows. So my data gets loaded. Now I will show you its unique values. Means what are the unique values in the output column. Okay, data dot unique. Okay, so these are three different categories. These are three different categories of flowers we have in our output, and these are its input columns. On basis of these input columns, it affects our output, right? It will like decide my flower is Setosa or versicolor, anything, any flower. Okay. Now I will show you by plotting a pair plot how it is looking like uh, on these four inputs. I will show you. Data is equal to data because I have loaded my data set in data variable. is equal to species I will give. Okay, of plt dot show. Now, first look at the colors. Okay, Setosa for blue, Versicolor for green, sorry, orange, and green for Virginissa. So these are three different colors for different categories, different species of flowers. Okay, now look at sepal length, sepal width, and petal length, petal width. Okay, these are the four uh, basically inputs. These are the four inputs. Okay, so how it is looking like? Look at this. For sepal length, it has higher values. Means I have higher setosa for this. Look at this. This is how it's looking like, right? So I have shown you the how it is looking like, how it is separated, how it is like, how it is looking like into my graph. Okay. So now I will separate my data into input and output. I will use ilog. I will say give me all rows and give me all column, but don't give me the last column minus one. Last column because this is my output column and I will take my output column into Y. All the input columns I have taken in X and in Y I am taking output column. Okay. Now now I will now I will divide the data set into training and testing data. Right. First I will import train test split from scalar dot model selection, import train test split. Okay. Now I will take my all four variables x train, x test, y train. These are the things I have already discussed. You can check my previous video of train test split is equal to, I will call my train test split for which variables x and y, right? Now I'm taking test size as 20%. I want 80% for my training data and 20% for testing data. So I will write test size is equal to 0.2 random state is equal to 42. Okay, now my data gets divided into training data and testing data. Now, first method was my multinomial method, right? Multinomial method. We will see that. I will give a markdown here. Multinomial method. I will choose markdown and shift plus enter. Now, my multinomial method. I will first give, first I will import logistic regression, sklearn dot model selection, sorry, linear model, linear model, import logistic regression. Okay. spelling mistake. Okay. Now, suppose I will give an object to call my logistic regression. Now, here for multinomial method, because we are not applying a direct method, we are applying multinomial method. I will have to give, suppose, shift plus tab use. Now, see, here you have to use solver. Solver. Okay. For multinomial method, we will use this solver because this solver is fast, stable, and supports multinomial losses. Okay, this is because of it we are using this solver. Okay, now again when you will click shift plus tab, you will click here, then you will get this. Okay, max iteration. Suppose I will give 1,000. Let's say I will give 1,000. Basically, max iteration, if I will give 1,000, it will allow our model to train longer. Okay, this is what it means. Okay, I have explained both of this. Okay, so now step plus enter. Now, fit your training data for your model, X train, comma Y train. Okay, now my data model gets trained by my training data. Okay, now suppose I will check accuracy of my model, comma Y test. See, it is giving 100% accuracy. Okay, it is giving 100% accuracy because this data is very good data, iris data set. This is because uh, that's why we are getting 100% accuracy. See, we looked how multinomial method works, how we can use multinomial method, okay, and why it is used. Okay, now we will see OVR method. Okay, OVR method. Now, for first, again, I will give a mark now for using OVR method because I will give you the notes also. OVR method. For using OVR method, we will first have to import one versus rest classifier. Okay, from sklearn dot multiclass import one versus rest classifier. Okay, now suppose I will give a second object lr2 is equal to, I will call my rest one versus rest classifier. Now in this I will use logistic regression. I will use my logistic regression. Now, now in this we will suppose I will check shift plus tab. Now in this we will give our solver is our solver as linear. Okay, suppose I will take this. I will take linear in. Why linear? Because linear basically works better for binary classification. Okay, binary classification means, see what OBR method does. I've already explained. One versus rest. For basically three classes, it will build it will build basically three different models, and in one model, it will it will check one class versus others, right? So that's why we are taking solver is equal to linear. It is better for binary classification, and I will again take max iteration as max iteration at 1000, so that my model gets trained longer. Okay, so if plus enter. Now I will fit my uh, training data for my OBR method. Dot fit x test y test. No, it gets fitted. Okay. Now I will check the accuracy again. LR2 dot score. I will give my x test comma y test. Hit plus enter. Yeah, it is giving 86% accuracy. It is not that much good accuracy, but yeah, I am getting 86% accuracy in my OBR method. Okay, so for now, for my model, multinomial method is good. So from OBR method, we are getting slightly low accuracy. Now, direct method. Direct method is very simple. Just apply your logistic regression. Okay, I will give markdown, shift plus enter. Now, LR3 is equal to call your logistic regression. Okay, now fit your training data, X train, Y train. Now, check the accuracy. 3 dot score. We will give X test, comma Y test in 200. So it is also giving me 100% accuracy. So we saw how we can use different methods of logistic regression for multi-class classification. Okay, so we have seen all three methods for multi-class classification by logistic regression. Okay, so that's all in this video. For the next video, we will discuss confusion matrix. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss confusion matrix. So what is confusion matrix? A confusion matrix is used to check how well a classification model is performed. Okay, it compares actual values and real answers. Okay, my actual values and answers or outputs we are getting from the our model predictions. Okay, predicted values, model prediction. Okay, it compares this. Okay, it helps us to understand how many predictions were correct and where the model made mistakes. Okay. Now suppose I have positive class is equal to 1, negative class is equal to 0. Okay. Then the matrix will be look like this. Actual 0, Tn, actual 1, predicted 0, Tn, predicted 0, Fn for actual 1, and predicted 1, Fp and P. What it means? True positive. Okay. TP means, first TP means true positive. Means model predicted positive and it was actually positive. Okay. Next TN, true negative. Model predicted negative and it was actually negative. So these are two correct ones. Okay. Now false positive and false negative. FP. Model predicted positive but it was negative. Okay. Now, false negative. Model predicted negative, but actually it was positive. Okay. So these two are for calculating wrong and these are for calculating right. Okay. Means these two are for giving right output and these are two for giving wrong outputs. Okay. Now, now for confusion, when we will build confusion matrix, we will get these four values. Okay, how much true negatives, how much false positive, how much false negative, and how much true positive. And these terms have these meanings. Okay. Now, on the basis of this confusion matrix, we calculate accuracy of the model. What is the formula of accuracy? Accuracy means overall correct predictions. Okay, accuracy is equal to TP plus TN means all true means right outputs upon all the outputs. Right outputs means these two outputs upon all outputs. Okay, so this is the formula of accuracy. Now, precision. Precision means out of all predicted values, how many were actual positive? TP, we will take only true positive TP and upon TP plus FP, true positive and false positive. Okay. Same recall out of all actual positive, how many were correctly predicted? TP upon TP plus FN. TP means true positive and upon true positive plus false negative. Okay. And F1 is score. F1 is for balances, precision, and recall. These two. Okay. This is the formula of F1 is good. F1 is equal to 2 into precision into recall. Precision into recall upon precision plus recall. Okay. Got it? What is the meaning of these terms? Okay. So I will show you practically how we can use confusion matrix to perform these things, to calculate these things. Okay. First, I will show you how to calculate, how to create confusion matrix using Python. In Python, it is very simple. We can do by only scikit-learn. Okay, so we will see that on this placement dataset, I will perform confusion matrix. Okay, so now let's see how we can do it practically. Okay, first I will import some libraries. Import C1 as SNS. Okay. Now I will load my data set. Data is equal to pd.read slash csv. I will give the path of my csv file. This is my file. Copy path. Control V. I will check my data is loaded or not by checking first three rows. Okay. These are three. These are three are my first three rows. Okay. Now, now I will first divide the data set into input and output. For input columns, I will I will basically store in X, and output column I will store in Y. I will I will use ilog, give me all rows and give me all column, but don't give me the last column. That is output column. Okay. Data plus enter. Now my data gets divided. Okay. Now now I will now now I will basically I will divide the data set into training and testing data. Okay. Now from sklearn dot I will import train test split. Okay. Model selection, import, import train test split. Okay. Now now I will divide my data. I will take my all four variables for dividing my data set into training data set and testing data set. Equal to x y. I will take test size as 0.2 for means it means 20%. I'm taking the testing data from the total data. Random state is equal to 42. Okay. Oh, sorry. I forgot to call train test split. Okay. Now my data gets divided into training data set and testing data set. Okay. Now, now I will build the model from sklearn dot sklearn dot linear model import import logistic regression. Okay. Now I will build the model. First, I will take an object LR. I will call logistic regression by this object. Now I will fit the training data into my model. X train, Y train. Okay, it gets fitted. Now, now I will check my score, means accuracy. So 83%, 83.6% is my accuracy I got. This is what accuracy means: true positive plus true negative upon all the addition of all these four values of all these four terms. Okay. So I have already described what is the meaning of these terms. Okay. Now, now I have calculated the accuracy. Okay. Now I will create a confusion matrix CF. Suppose CF is equal to first I will import this sklearn dot matrix import confusion matrix precision is precision score, recall score, and last one F1 score. I will import all these four from a scalar. Okay. Now, okay. Simple is a spelling mistake. Now, I have imported all these things. Okay. Now, let's say I will create a confusion matrix. F is equal to, let's see, I will call this confusion matrix. I will take y test lr dot predict x test. Okay. X test. Right. Now I will see it. Now see, I have created confusion matrix. Now we got all four values. What is the meaning of these four values? 1670 is your true negative. True negative. True negative means model predicted negative and it was actually negative. Okay. So this is the correct answers which I got 1670. Now 4. 4 is equal is your FP false positive means model predictive positive but actually it was negative. Okay, so there are total four values like this. Okay, 324 is your false negative means model predicted negative but actually it was positive. Okay, so how many values are like this? 324 values are like this. This is very high value, high number of values. Okay, 2. 2 is your true positive, means model predicted positive and it was actually positive. So there are only two values for this. Okay, so this is a quality of like a poor model. Okay, this is not a good model. Okay, this is what I got from creating confusion matrix. Okay, now, now, now I will calculate all these things: precision score, recall score, and F1 score. Okay, first I will give a markdown that for a good model, all these values should be high. Precision score, recall score, F1 score, all these values should be high for a good model. Okay, I will write this. All these values should be high for a good model. Okay, I will give a markdown, shift plus enter. Okay, now, now I will calculate all these things. Okay, I will take this. This is the score. Sorry, same. I will take y test. I'm comparing from what test and what my model predicts. LR dot predict for X test means our training which I have basically What are my X test? My X test is the testing value of my input call. This is what my X test. So what is my model is giving prediction for those X test. X test into 100. Only 33.33. This is very low. So this is a sign of this is not a good model we have. Okay. Again, now this time I will calculate recall score. Only 0. See, I have multiplied it by 100. After that also I'm getting 0.61. Again, this is very low. So this is not a good sign for my model, which means this is not a good model we have built, right? Now last one I will calculate F1 score. I've already described these terms: true negative, true positive, false negative, false positive, and all these things. Accuracy, precision score, recall score, right? Now I will again take this. Now see, only 1.20. This means if these values are not high in classification algorithms, then this model is not good. Okay, these values should be these all values: accuracy, precision score, recall score, F1 score. All these four values should be high. Then only we will think we will get a good model. Okay, so we got the we have discussed the confusion matrix topic, and all these confusion metrics, precision score, accuracy, recall score, we have discussed. Okay. Now, in next video, we will see how to deal with imbalanced data set. Okay. Thank you. Hello guys, welcome to the channel. Today we will discuss imbalanced dataset and how to handle imbalanced dataset. An imbalanced dataset means one class has much more data than the other class. What it means? Suppose from a dataset, I am predicting patient have that disease or patient do not have that disease. Okay. So in our dataset, 950 data points for zero category means no disease category. Okay, there are 950 data points, mean 950 rows, and only 50 rows or only 50 data points are for one. So this is much higher than this one, one for disease. Okay, so this is a kind of imbalanced data set. Okay, this one category has much higher data points than this one. So this is a kind of imbalanced data set. So we need to fix it. Why do we need to fix it? Because when you will build the model on this kind of data set, then model will predict more in most of the cases zero, because this data point has this zero has much data more data points than this one. Okay, so it will predict in most of the cases zero. Okay, so that's why we need to fix imbalanced dataset. So there are two ways to fix imbalanced dataset. First is oversampling and second one is undersampling. Understand what oversampling do? In oversampling, we increase minority class samples, add more data to smaller class. What it means? This is our minority class, right? This is the we increase minority class and more and add more data into smaller class. This is our smaller class or minority class. we will add more data points to this one by oversampling. Okay. And what is undersampling? We reduce the majority class samples and remove some rows from larger class. We will basically delete some data points from majority class, means the larger class. Okay, to fix imbalance data set. So I will show you how we can do it practically. On this data set, I will perform oversampling and undersampling. Okay, this is our input column, age, and purchased or not purchased. It is my output column. Okay, so we will see how we can do it practically. First, I will import my Pandas library. Okay, now I will load my data set. This is my data set. Copy path, Control B. Check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and these are its first three rows. Okay. Now first I will show you how many zero, how many data points for zero and how many data points for one in purchased column. Okay. Dot value counts. Okay. So here you can see I have data points 257 data points for zero and 143 data points for one. Zero have some higher data points than one. Okay. So this is a kind of imbalanced data set. So we need to fix this. Okay. First, I will divide my data set into input and output. Age is my input column and purchase is my output column. Age is my input column and purchase is my output column. Okay. Now I have divided my data set into input and output columns. Okay. Now now I will split my data set into training data set and testing data set. Okay. Dot model selection import train test split. Okay. I will take all four variables for splitting my data set into training data and testing data. Okay. X train, X test, Y train, and Y test is equal to, I will call my train test split X and Y variables in which I have divided my data set into input and output. I will take test size as 20%. I will write 0.2 and random state is equal to 42. Okay. Now, now I will build the model from sklearn dot linear model import logistic regression. Okay. Now I will create an object to call my logistic regression. Now I will fit my training data into logistic regression. Okay. Now it gets fitted. My model gets trained. Now suppose I will check my accuracy of the model into 100. So I'm getting 91% accuracy, which is a good accuracy. But although this is my imbalanced data set, we saw the values 257 data points for 0 and one only 143 for 1. So we need to fix it. First, we will see our undersampling method. Okay, undersampling method. Under, I will give a markdown. Okay, and undersampling. What we do in undersampling? Undersampling, we reduce majority class samples. Means we will decrease this higher data points category. Okay, in undersampling. Okay, now from IMB learn. IMB learn means imbalanced learn dot undersampling import random under sampler. I will import this. Okay. Now suppose I will make an object to call random under sampler. Okay. Now I will create a new RUX and RUY for different input and outputs. Basically, resample my X and Y, which is my X and Y have input column and Y have output column. I will resample it. Okay. Dot get resample X and Y. X and Y. Okay. Now, we will check value counts for RUX and RUY. Okay. Now, sorry, for RUY, because RUY will have the output column. Okay. Y dot value count. Now see, it has decreased to 143. See here. I had 143 data points in hour 1 and 257 for 0. So in undersampling, we decrease the higher data points, which category have higher number of data points. We decrease that in undersampling. So what we did, we decreased the data points of zero category. Okay, zero category. So now it has equal number of data points. Okay, so we have decreased the data points of higher number of data points. Okay, in zero. now Now second one is our, now you can basically split the data set on the basis of RUX and RUY. I have resampled it. So here you can give RUX and RUY. Okay, and you can give LR2 is equal to logistic regression, and now you can fit the data into new four variable. Basically new X train and Y train, because we have resampled X and Y. Okay. 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 It gets fit. Okay. Now my second method is oversampling. Okay. I will give a markdown. Sorry, I will give a markdown here. Shift plus enter. Now, what we do in oversampling? In oversampling, we increase minority class samples. Means we will increase the data points of one category. Okay. Now, how we can do that? Same, I will copy this from learning, imbalanced learn, sorry, oversampling. I will be oversampling, and I will import random oversampler. Okay, I have imported this. Now, suppose I will create a new object for this. RO is equal to. Now, I will call random oversampler. Okay, now I will create new x and y. ROY is equal to, again we resample ro dot fit resample. What we will resample x and y, in which I have given input column and output column. Okay, resample it. Now I will check the value counts for my ROY value counts. Now see what we do in oversampling. We increase the uh, less number of, basically we increase the data points of that category which has lower number of data points. In our case, one has lower data points. So here you can see now both have equal 257 and 257. In beginning we had 257 for 0 and 143 for 1. So I have increased the data points of 1, and in undersampling I have decreased the data points for 0. Okay, this is what oversampling and undersampling do. Now again we can do same. Okay, here I will give ROX and RON. Okay, now I can build a new model. So I will give LR3. Okay, now again I will fill LR3 dot fit extend wide. Okay, now so we saw in this video how we can handle imbalanced dataset using undersampling and oversampling. In undersampling, we decrease the higher number of data points category into lower, and I have increased the data points of lower number of data points category. Okay, okay. So in next video, we will see naive Bayes algorithm. Okay, so that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss naive Bayes algorithm. So what is naive Bayes? Naive Bayes is a classification algorithm based on probability and the Bayes theorem. We all studied Bayes theorem in probability and statistics, and it predicts the class or category of data using probabilities. Remember, using probabilities. Okay. For example, spam or not spam email, positive or negative review, disease prediction, news category prediction. So this is on which naive Bayes algorithm works. Okay, this kind of examples. Okay. So what is Bayes theorem? Bayes theorem is A by B is equal to PB by A into PA upon PB, where P A by B is equal to probability of A given B, P B by A is equal to probability of B given A, and PA is your prior probability and PB is your total probability. We have all studied Bayes theorem. Okay. Now, there are three types of naive Bayes algorithm which you can use practically. First is Gaussian naive Bayes, second one is multinomial naive Bayes, third one is Bernoulli naive Bayes. So now we will see when we use three different types of naive Bayes. So when we will use Gaussian naive Bayes, when data is continuous numerical data. Continuous numerical data. Data follows normal distribution, means bell curve. Okay. For example, our features will be height, weight, right? So in this kind of things, we will have continuous numerical data. So we can perform Gaussian and beyond that. Okay. Now second one, multinomial neighbors. When we will have textual data, text data. Okay, data is discrete or count based. Okay, so it is mostly used in natural language processing. Okay, so we will cover that also. Bernoulli and Bernoulli neighbors. When we will have binary features, for example, 0, 1, true, false, yes or no, then we will use Bernoulli neighbors. So I have explained when we can use Gaussian NB, multinomial NB, and Bernoulli NB. Now, I will show you how we can perform these three on basically practically on a data set. So I have this data set on which I will perform all three types of naive Bayes algorithm. Although it will not like satisfy the condition for some algorithms. For example, Gaussian NB, it is like satisfying the need for Bernoulli NB because I have 0, 1 category here, only two categories, binary features I have. So yeah, but although my objective is to basically give you an idea how we can perform these three different type of naive Bayes algorithm practically. Okay, so now we will see how we can do it practically. Okay, first I will import my pandas libraries, pandas as pd. Now I will load my data set pd.read/csv. Now this is my data set. I will right click, copy path, control V. Now data dot head. I will check my first three rows. My data gets loaded or not. Yeah, my data gets loaded. Okay. Now, now I will separate my data into input and output column. In X, I will take all input columns, these two columns, and in Y, I will take our output column. Okay. X is equal to data. I will use ilog. I'm saying give me all rows, give me all columns, but don't give me -1 means last column. Okay, because this is my output column. I will take my output column into Y. Okay, I will copy it. Sorry. Okay, now shift plus enter. Now my data gets divided. Okay, into input and output. Now I will divide my data set into training data set and testing data set. I will take 80% for the training and 20% for the testing. Okay. Now I will import train test split dot model selection, import train test split. Okay. Now, now I will take my all four variables x train, x test, y train, and y test is equal to. I will call my train test split for which variables x and y. I have taken my input and output. I will give test size as 0.2 because I want 20% as my testing data. Now, random state I will choose 42, right? Now, my data gets divided into training data set and testing data set. Now, I will perform all three different types of algorithms of naive Bayes one by one for this data set. Okay. Now, first I will import all three algorithms of naive Bayes sklearn dot naive Bayes naive Bayes naive Bayes import first Gaussian NB. Second one is our multinomial NB. Multinomial NB. I've already explained when we use Gaussian NB and multinomial NB and Bernoulli NB. Okay, but I'm just showing you on this data set only by applying all these three algorithms. Okay, Bernoulli, Bernoulli NB. Okay, I think I have did some spelling mistake here. So I will just copy paste. Okay, double L. I think I missed double L. Okay, okay. So I have imported all this. Okay. Now, first, suppose I will make an object to call Gaussian NB. G and B I have taken an object. Okay. Gaussian tab. Now, we can call it. Okay. Now, I will fit my X train and Y train into Gaussian NB, X train and Y train. Okay. Now, it gets fitted for my Gaussian NB. Okay. Now, I will show you, suppose, accuracy of my model. Okay. For X test, Y test into 100. Suppose I will show you the accuracy of training also. Okay. I will give train. Okay. Now, so 83% accuracy we are getting for our testing and training both. Now I will use multinomial MNB is equal to, I will call my multinomial. Okay. Now I will fit I will fit my training data for multinomial here. I will just, okay. Yeah, it gets fitted. Now suppose I will check the accuracy for this MNB and MNB. So same accuracy it is showing. Okay, for my Gaussian NB and multinomial NB. Let's check Bernoulli NB. BN Bernoulli. Okay. Now suppose I will fit my training data for Bernoulli. Now BNB. Okay. Sorry. BNB. Okay. Yeah, it gets fitted. Now suppose I will check my accuracy for Bernoulli. Yeah, it is giving accuracy for all these three algorithms of naive Bayes. Okay, so we saw in this video how we can use different types, three different types of naive Bayes algorithm. When we use these three different types of algorithm, in which cases I explained already. Then we checked how to use these three different types of algorithm, Gaussian NB, multinomial NB, polynomial NB on a data set. Okay, so that's all in this video. In the next video, we will start our non-linear supervised learning algorithms. Okay, so that's all. Thank you. Hello guys, welcome to the channel. Today we will discuss what is non-linear supervised learning and how to use decision tree algorithm for classification. Okay, now first, what is non-linear supervised learning? Non-linear models can learn curves, complex patterns, multiple decision boundaries. Like in supervised, like linear supervised learning, we saw when we draw the graph between the dependent variable means your output and independent variable means your input. When we draw that graph, you saw linearity between them, right? But in non-linear supervised learning, like we will not see linearity, right? It may form curves, it may form the complex patterns, okay, anything. Like it will not follow linearity, right? So to counter non-linear supervised learning, we have some algorithms, okay, like decision trees for both regression and classification, random forest, SVM, neural networks, and KNN. These algorithms we use for non-linear supervised learning. Okay, now it means instead of drawing a straight line, they create complex regions. For example, see, this is a kind of graph. Assume that. Okay. Now you will able to see here there are two types of categories here, blue and red, right? So this is how these algorithms divide these two categories. Okay, divide the two categories. Maybe sometimes like it will not be accurate 100%. For example, you can see a blue is coming in red area, right? So this can happen. But overall, these algorithms, this is how they separate different different categories, different categories. This is how they separate, right? So for example, simply a real life example, we will see. Suppose you want to classify fruits. Okay. Rules means you have features. Means if color is red and size is small, it will be cherry. If color is yellow and size is long, it is banana. If color is green and round, then it is apple. Okay. So when you will basically draw a graph for these features and your output, it will not follow a straight line relationship, right? So this is where decision trees works and all these algorithms. First we will see decision trees, then we will cover these algorithms also. First we will see decision trees. Okay, so decision trees for classification. Okay, remember we are using for classification. I will show you for regression in the next video, but in this video we are using decision tree for classification. Okay, so what is a decision tree? A decision tree works like a flow chart. Okay, it asks questions step by step and reaches a final decision. Okay, what it means? Basically, understand in a simple language. Okay, suppose it will first create a condition. Is age is greater than 18? Two possibilities, yes or no? Yes. Then again ask a question, if he is 18 years old or he or she is 18 years old, then they have a job? Yes. Okay. Yes, then loan is approved. If they not have a job, then loan is rejected. Okay. Now, if his age is greater than 18, we saw what are the different categories can happen by year. Now, simply if he or she is not 18 years old, he is or she is less than 18 years old, then loan will be rejected simply. So this is how they basically classify the problem into each step. How this is how decision tree works. Okay, tree keeps splitting data based on conditions. You can see example of decision tree. Age is greater than 18, divided into two parts. Yes, no. Yes, then income is 50K. It can be yes or no. It is no. Suppose age is less than 18, no, then reject. Income is greater than 50K, yes, then loan approved. If income is less than 50K, then loan rejected. Okay, so this is how they basically classify the problem into each step. Okay, and reaches to a final decision, right? A loan is approved or not approved, right? This is how decision tree works. Okay, goal of decision tree, main goal, create pure nodes. Okay, pure node means all outputs inside node belongs to same class. Example, yes, 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 this is pure. Suppose in this approve, it will classify this is a pure node, and in no, reject. This is this will be a pure node, two different pure nodes. So its main goal is to separate both categories. Okay, and each category will lie into its perspective category, not like randomly. Suppose approve, reject, approve. This will be an impure. Okay, this is this uh, basically through decision tree we can basically divide the classic categories. Okay, so this is how decision tree works, and I have already explained what is the meaning of nonlinear supervised learning, and these are its uh, algorithms for regression and classification both. First we will see decision tree for classification practically. Okay, now suppose this I have this data set. I have used this data set previously also. So on this data set we will see our decision tree classification. Okay, let's see how we can do it. First I will import some required libraries. Import pandas svd, import import matplotlib dot pyplot as plt, import seaborn as essence. Okay, now suppose I will import one more library. Okay, ml extend. Okay, from that I will import plot decision regions. Okay, so if you don't have ml extend, then you can download it by giving this prompt pip install ml extend into your cmd. Okay, it will be installed in your system. Okay, now from ml extend I will draw a decision tree, basically decision tree graph, how decision tree works. Okay, by ml extend. Okay, ml extend dot plotting, import plot decision results. Okay, now I've imported it. Okay, now I will load my data set. Data is equal to pd dot read slash tsv. This is my data set, non-linear, copy path, control v. Now I will check my data is loaded or not by checking first three rows. Yeah, my data gets loaded, and these are its first three rows. First, I will show you by plotting a graph that it is a kind of non-linear graph, right? Scatter plot, scatter plot, x is equal to age Y is equal to, I will take estimated salary and Q is equal to purchase. Okay, I will be purchased. Okay, now I will give data is equal to data. My data is in my data variable. I will write plt dot code. Okay, now so you can see here this is randomly plotted, right? This is not following linearity from anywhere, right? It is randomly, basically it is randomly existing. Okay, so now now I will divide my data set into input and output. My input fields are take all the rows, all the columns, but don't take the last column. Last column is my output column. I will take my last output column in Y. Okay. Now my data gets divided into input and output. Now, now I will simply basically I will basically standardize these two columns because you can see here this age column will have this age column has lower values and it has higher values. So our model, when I will train the model, then it will give more priority to estimated salary because it has higher value. So which is wrong in our case. So I have already explained in our previous video how to perform standardization. So you can check my video. So first I will standardize. Basically, standardize means we will scale the data. Scale the data into the form 0 to 1. Okay. And like that. Okay. From Scikit-learn dot pre-processing import standard scalar. Okay. Now, suppose I will create an object to call standard scalar. Now I will fit my x because all input columns into my x. So I will standardize my x variable in which I have age and estimated salary columns. Okay. Now I will I will create into transform into data frame sc dot transform what transform x. Now I will convert it into columns x dot columns. Okay. Now if you will see here your x, now see. Now it has scaled my age and estimated salary, right? Before it was looking like that, now it is looking like this, right? So now I will split the data set into training data set and testing data set. Okay, 80% for the training and 20% for the testing. Okay, from sklearn dot model selection import train test split. Okay, now I will take my all four variable x train X test, Y train, and Y test is equal to, I will call my train test split. I will give my X and Y variable. Test size I want 20%, so I will write test size is equal to 0.2 and random state is equal to 42. Now my data gets divided into training and testing. Okay. Now I will basically create the model. Okay. Now from sklearn dot tree import decision tree classifier. Okay. Because we are handling our classification problem, that's why I'm importing decision tree classifier, right? Now suppose I will again create an object to call my decision tree classifier. Okay. And I will fit my training data into it. X train and Y train, right? I will fit the model. It is fitted. Now suppose I will check my accuracy of the model. dt.score X test, comma, Y test. So suppose I will into 100, I will multiply it. So it is giving 83% accuracy. Okay. Now I will show you how my decision tree is working on our data set. Okay. For that, I will basically plot our decision tree for it. Sklearn dot tree import plot tree. Okay. Now suppose I will plot my plot tree. What I will plot? DT, right? DT decision tree and PLT dot show, right? Yeah. Suppose I will give some big size. Bigger big size is equal to, suppose I will give 30 comma 30. Yeah. Not, it is still not visible, so I will make this to 50 to 50. Okay. Now it is slightly visible. Okay. Now see here. Suppose I am making more bigger because it is Still not visible. Okay. So slightly you can see here. This is how it is dividing the data set. Okay. It is how dividing the data set. Suppose first let's say I will take some max depth. Okay. Because it is using all depths here. So I can limit the depths also, right? So this is one depth, this is two, this is three. I can limit that also. Okay. How we can limit that? Uh, here you can write, here you can write max depth is equal to, suppose I am taking four. It increased increased its accuracy also. See here. By applying max depth is equal to 4, the accuracy also improved of my model. Okay. Now you can see here. See, first, this is my age. Okay. This is my age. X0. Okay. Guinea is something how pure your data classifying. Okay. Samples 320 means there are total 320 samples. Means there are total 320 rows. Okay. Now value is equal to 205 and 115 means for zero means not purchased zero. I have 205 rows, and for one it means person have purchased, there are total 115 rows. Okay. Now it divided true and false. Now you can see, now my total age is 0.61, we need 0.3, and here 0.273. Now my uh, total rows are 234 here, and total rows are 86 here. 191 for 0, 43 for yes, and 14 here 14.0 for no, 72.0 for yes. So this is how it is basically dividing my data set, dividing the problem to take a decision, right? So this is how it is classifying. Okay. So this is you got to know how decision tree works. It divides the problem basically. True, false. It divides the total problem, right? Now, suppose I will plot a graph to show you how it is separating my data into two categories, because I have only two categories, 0 and 1. So I will show you how it is classifying. I will use PLT decision reasons. Here we need to convert it into NumPy, X to NumPy, and Y for also. Y also I need to convert it to NumPy, right? CLF is equal to your DT. Now PLT dot show. Okay, plot decision reasons. I have written PLT. Yeah. Now here you can see I have I have this date. I have randomly it was uh, occurring in my graph. You can see here both orange and blue, two different categories were randomly occurring. Now it classified. How it classified? Suppose first here blue classified. See here some yellows also, but yeah, overall my blue part is covered, and into my orange part there are some blue parts also here. Here it it has taken a blue. Some blue parts are also here. But overall data it has categorized into two different regions. Okay. So we saw uh, how decision trees works. Okay. So always check. Suppose you have not suppose here you have not given max depth. Suppose you have not given max depth. Your accuracy is coming low. So always check on max depth by applying different max depth like 3, 4, 5, 2, 6. Always apply and check your uh, accuracy. How much accuracy is you're increasing or decreasing? Always check by max depth how much depth you want to use. You don't need to always take all the depth, use all the depth. You can check by applying max depth. I want only four depths, till four depths. So you can apply. So we saw by applying max depth is equal to four, my accuracy was improved, right? So this is how decision tree works, right? For classification problem. So that's all in this video. From in the next video, we will see how we can use decision tree for regression problem, right? Okay. So thank you. Hello guys, welcome to the channel. Today we will discuss decision tree for regression. In previous video, we saw how we can use decision tree algorithm for classification, and now in this video, we will see how we can use decision tree algorithm for regression. Okay, so what is decision tree regression? It is a supervised machine learning algorithm used to predict continuous numerical values. What do you mean by continuous numerical values? For example, I have house price prediction, salary prediction, temperature prediction. Like instead of predicting categories like yes, no, spam, not spam, this is a type of classification. Okay, this we can predict decision tree. This we can predict in classification by decision tree. This is an example of basically classification. So for regression, instead of predicting categories, it predicts continuous numerical values. Suppose like for example, salary 5 lakh, like temperature 45.7, something like 1200. Okay, so this is what we predict through decision tree for regression problem. Okay, so how it works? Simply see, same like classification problem. It splits the data, basically classifies the problem into step by step, yes, no form, like classification. Also, it works for regression also. Okay, so, like, suppose I have experience is less than 5. There are two conditions. Yes, experience is less than 5. Yes. Is experience is less than 5? No. Experience is greater than 5. Yes, no. For whom whose experience is less than 5, their salary is 25K. But whose experience is more than 5, their salary is 85K. So this is how it classifies the data, okay, and predicts the continuous numerical values like house price prediction, salary prediction, temperature prediction, okay. So this is how decision tree works for regression, okay. So on this data set, I have this as input column, years of experience and their salaries. Okay. On this data set, we will perform our decision tree algorithm. Okay. Now, let's see how we can do it practically. Okay. I will reopen it. Now, first, I will import my required libraries. Import pandas as PD. Import matplotlib dot pyplot as PLT. Import Seaborn as SN. Okay. Now, now I will load my data set. Data is equal to pd.read slash csv. So this is my data set. I will right click, copy path, control V. Now I will check my data is loaded or not by checking its first three rows. Yeah, my data gets loaded and these are its first three rows. Now I will plot a graph. Okay, how my data is looking like. Okay, I will give data is equal to data because in the data variable I have saved the data. Now plt dot show. Yeah, this is how data is looking like by plotting pair plot. See, first I had years of experience, then I had salary. See, this is how my graph is looking like. Okay, now, now first I will split the data set into input and output. First I will take my input column, although I have only one input column and only one output column. Output column basically always be one. Y is equal to data. I will take my output column, which is my salary. Okay. Now, my data gets divided into input and output. Now, now I will split the data set into training data set and testing data set. I will take 80% for the training and 20% for the testing. Okay. Now, from sklearn dot model selection import train test split. Okay. Now, I will take my all four variables x train, x test, y train, y test is equal to I will call my train test split now for x and y variables because I have input and output in x and y variable. Now I will take test size is equal to 0.2 as I want 20% of my data set as my testing data set. I will write random state is equal to 42. Okay, now my data gets divided into training and testing. Now, now I will build the model. Okay, now from sklearn dot tree import decision tree regression because we are dealing with regression problem. Sorry, regression and plot tree also. I will draw the tree for you. Okay, now suppose I will create an object to call my decision tree regression. Suppose I'm not giving any max depth now. I am fitting my X train and Y train for training the model. Yeah, my training, my model gets trained. Now, suppose I will check my accuracy of the model. X test, comma, Y test into 100. So, 93% accuracy is coming. Okay. Now suppose I will show you how it breaking our data step by step, step by step. Okay. Now, suppose I will take some page size is equal to 50, 20, let's say. I'm taking now plot tree. I will take DT because in DT I have fitted the model. Right now I will write plt dot show. Okay. So like suppose I will give max depth, some max depth I will give. Suppose I'm giving max depth as 3. You can give, you can check the max depth, okay, by giving 3, 4, 5 like this, okay. Yeah, my accuracy is decreased, little bit decreased, okay. But tree I can see now clearly, right? So here you can see first x0 is less than or equal to 0.35. First condition is put x my years of experience is less than or equal to 6.35. Okay. Now squared error we already discussed it. This is our squared error. Samples there are total 28 samples. Okay. Value is equal to 81164. This is your salary. Now, first condition is true. If X is our years of experience is less than or equal to 6.35, then true. Then here it classifies. Now X is less than or equal to 2.55, and this is the salary, and total samples are means total rows are 17. Now, second thing, it false means our years of experience is greater than basically greater than 6.35. Then again it broke. X is less than or equal to 9.95 years of experience, and my salary is this. Okay. So this is how it splitted my dataset to get a final decision. Okay. So this is how decision tree works for regression. Okay. Similarly, like classification. In classification, we take decisions for categories, and in regression we take decisions by decision tree for numerical continuous values, right? Like salaries, house price predictions means price of the house. Okay. So this is how we use decision trees for regression problem. Okay. So that's all in this video. In the next video we will see KNN algorithm for classification. Okay. Thank you. Hello guys, welcome to the channel. Today we will discuss KNN algorithm for classification. So first understand what is KNN, K nearest neighbors. K nearest neighbors is a supervised learning algorithm used for classification and regression both. For classification predicting categories or classes, and for regression predicting numbers, right? In KNN classification, for classification, the model predicts the class of a new data point by checking the nearest data points around it. What it means. Suppose I will explain you by a real life example. Suppose you have two fruits, apple and orange. Okay. Now you get a new fruit. Okay. But you have to predict in both of these two. Okay. Now which fruits we will check by KNN, which fruits are closest to this new fruit. Okay, apple or orange. Okay, suppose if most nearby fruits are apples, okay, to our new data point, then model will predict apple. And if my most nearby fruits are oranges to my new data point, then it will predict orange. Okay, So this is how a graph, an example of graph where I have two categories, 0 and 1. And this is how it tries to extract the same categories by calculating the distance between these data points. Suppose this is 1 for green, 0 for red. So you can see some red are there in green part also. Okay, but what it is trying to do is it is calculating the distance between the data points, each data points, and for closest data point, it tries to extract them together. Okay, means it is categorized different categories on the basis of their distance. Okay, so greens are almost close to each other, reds are mostly close to each other. So this is how it basically classifying the categories on the basis of the distance. Okay, so main idea of KNN is similar things stay close together. Okay, this is what I explained in the graph. KNN works completed based on distance. Okay, it finds nearest neighbors on the basis of the distance. Check their labels or classes like 0 or 1. Any classes, any kind of classes. Choose the majority class. Okay, so this is what I explained in the graph, and this is what the in theory main idea of KNN. Now we will check how we can do it, how we can perform KNN for classification problem practically. So this is my data set. Okay, this data set I have used previously also in my previous video also. So on this data set, I will try to perform my KNN algorithm. This is the kind of classification problem because I have only two categories, like two categories, or I have categories not like I have uh, continuous values like regression. So it is a problem of classification. Now we will see how we can perform KNN on this data set. Okay, so first I will import some required libraries. NumPy as np, import pandas as pd, import matplotlib dot pyplot as plt, import cborn as sns. Okay, now I have imported all the required libraries. Okay, so now I will load my data set equal to pd dot read slash csv because I have csv file. If you have Excel file, then you can write Excel. By the way, I'm giving the data set for every video. Okay, so this is my data set. I will right click, copy path. I will paste it here. I will check my data is loaded or not by checking its first three rows. Yeah, my data gets loaded, and these are its first three rows. Now, now I will show you how my data is spread through a graph. Okay, now I will plot a scatter plot. I will give x is equal to age. I will give y is equal to estimated salary, and I will give data is equal to data because in data variable I have taken my data set is equal to, I will give purchased. Okay, now plt dot show. Now you can see how my data is spread. Okay, this is how my two categories, 0 or 1, purchased or not purchased, is looking like. Okay, so we will see at the end by plotting a graph again how my data gets separated using KNN algorithm. Okay, we will see that. Now, first I will divide my data set into input and output. I will take all input columns in X and all my output column into Y. Data.ilog. So what are my input columns? Sorry, my all rows, my all column, but don't give me the last column because last column is my output column and these are my input columns, age and estimated salary. Okay, so I have taken X, uh, all input columns into my X and I will take output column into Y. Okay, Control C, Control V. Now my data gets separated into input and output by X and Y. Okay, now I will standardize these age and estimated salary columns. Okay, because you can see here age has lower values 1935 and estimated salary, obviously estimated salary will have more higher values. So my model will give more importance to estimated salary, which is wrong in our case because both columns are important for me. Okay, so I have already covered how to perform a standardize in detail. So I will perform standardize standardization sklearn dot pre-processing import standard scalar. Okay, yeah. Now suppose I will make an object to call standard scalar. Standard scalar. Okay, now I will fit my x into standard scalar because only input columns I want to standardize. Okay, so control sorry X I fitted. Okay, now I will transform it into columns. Okay, X is equal to PD dot data frames frame SC transform form X columns is equal to X dot columns. Okay, now I will show you the X. So you can see here my I have performed standardization. So you can check the values now. Okay, look at here and look at here. Okay, I have standardized my input columns. Okay, the data of input columns. Okay, now now I will split the data set into training data set and testing data set. Okay, for that I will import train test split scalar dot model selection import, train, test. split. Okay. Now I will take my all four variables x train, x test, y train, y test is equal to, I will call my train test split for which variables x and y. I have taken input and output columns into it, x and y. Now I will give test size is equal to 0.2 because I want 20% my for my testing data and 80% for my training data. Okay, random state is equal to 42. Okay, now my data gets split into training and testing data randomly. Okay, now I will build a model using k nearest neighbors, k nearest classifier because this is a problem of classification. So now we can make it from sklearn dot neighbors 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 import k neighbors classifier, k neighbors neighbors classifier. Okay, because this is the problem of classification. Okay, now suppose I will make an object to call my k nearest classifier. Now if you remember, in our decision tree, we used a parameter max depth. Okay, max depth we choose 3, 4, 5, anything. Similarly, in nearest k neighbors classifier, we can choose n neighbors is equal to 3, 4, 5. Suppose I will give neighbors n neighbors is equal to 3. What it means? Means I'm saying that look at three closest data points. Look at the three closest data points. Okay. That's what I'm saying by giving a parameter n neighbors is equal to 3. We can give 4, 5, 6, anything. Suppose I'm giving 3. Okay. In decision tree we saw we gave max depth is equal to 3. Suppose I'm giving n neighbors is equal to 3. Now I'm saying that look at the three closest data points. Okay, that's what I'm saying by this line. Now, I will fit my training data into it. KNN dot fit, KNN dot fit, X train and Y train. Okay, it gets fitted. Now, suppose I will check accuracy of my model. X test, comma Y test into 100. Now, 91% accuracy I'm getting. Okay. Now, I will show you by plotting a graph how my data is getting categorized, how my data is getting spread. Okay. I'm plotting a graph. Okay. From ML extend. If you have not ML extend, I have already shown in my previous video while covering decision tree for classification, how we can install ML extend. Only pip install ML extend. You want to give command in your CMD and it will install. It will be installed. Okay. Dot plotting import plot decision regions. Okay. Now I will call this plot decision results. Now we have to convert it into NumPy, also for y dot to NumPy, and we will take CLF is equal to KNN, right? CLF is equal to KNN. Now I will write PLT dot show. Now, now you can see how it tried to basically categorize my both features or both classes, or we can say labels. See, this is 0 for blue and 1 for this orange one. Now you can see some blue points are also there in my orange part, but it tried to cover that also. See here. Okay. So this is how it tried to split my categories or classes according to their distance. Okay. So this is how KNN for classification works. Okay. So in the next video, we will see how KNN works for regression problem. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss KNN for regression. So we saw in our previous video how we can use KNN algorithm for classification. Now we will see how we can use KNN algorithm for regression. Okay. Now KNN regression will predict the value of a new data point by looking at the values of its nearest neighbors. What it means? First, understand KNN is K nearest neighbor. K means number of neighbors. Nearest means closest data points. Neighbor is existing data points in dataset. Okay. Now, in regression, for regression problem, the output is continuous value, not categories like 0, 1, apple, or orange, not like that. It will be continuous value, not categories. Okay. For example, house price prediction, temperature prediction, salary prediction. Now understand this line. Predict the value of a new data point by looking at the value of its nearest neighbor. What it means? For understand by this real life example. Suppose you want to predict the price of a house, okay, and you have three inputs. On the basis of these three inputs, you are deciding what should be your price of the house. Okay, so by KNN for a regression algorithm, we will find the house prices which will be nearby that are similar in size, location, and room. Suppose suppose I have some size and location and rooms, and we are getting a price like 20, 30 lakhs. Okay, now suppose I have new data points, okay, new rows, which has similar size, location, rooms. Okay, so it will predict the price like in the similar way, like similarly like previous value, like its nearest value. Like then you take their prices and calculate the average of nearby data points, okay, of nearby prices of the house, and then it calculate the average, and then the average will become the predicted value. Okay, so that is how KNN for regression works. Okay, so we will see that how we can do it practically. So this is my data set. These two are my input columns, and this is my output column. On the basis of uh, on this data set, we will perform KNN for regression algorithm. Okay, so let's see how we can do it. First, I will import required libraries like import pandas, spd, Okay. Now I will load my dataset vd.read/csv. Now this is my dataset. I will copy path, control V, and I will check my data is loaded or not. Yeah, my data gets loaded, and these are my first three rows. Now we will see how we can use KNN algorithm for regression. Okay, so it basically tries to predict the output on the basis of its neighbors. Okay, like I have similar values in our input columns, and it predicts some value. Like I have some values, so it will try to basically put that new data point for the for that place, and it tries to basically calculates the average of those similar data points and similar outputs, and then the average will become our predicted value. Okay, now I will separate my data into input and output. I will take all rows, all column, but I will not take last column, -1. That is my output column. I will take output column into my data salary will be now. I will split the data set in training data set and testing data set. Okay. Now from scalar dot neighbors. Sorry. First I have to split the data set, right? So I will import model selection, import train test split. Okay. Now, now I will take all four variables: x train, x test, y train, and y test is equal to. I will call my train test split. Okay, MS balance. Okay, I will call my train test split for x y variables. I will give test size equal to 0.2. I want 20% as my testing data. Random state is equal to 42. Okay. Now I will create my model from sklearn. I will go for neighbors, import k nearest, uh, k neighbors regression, k neighbors regression, because this is the problem of regression. Okay. Now, now I will create my model. Suppose I will take an object to call my k neighbors regression. I will give some n neighbors. I have already explained what is n neighbors. Basically, suppose I will give n neighbors is equal to 3. So what we are saying, look at three closest data points. Only three closest data points. Look for only three closest data points. Okay. Now, So plus enter knn.fit. I will give my x train, y train. Okay. Okay. I have been wrong here. Yeah. Now it gets fitted. Okay. Now suppose I will check my accuracy. Score. I will give x test, y test into 100. So yeah, I'm getting 88% accuracy. Okay. Some things we can do, like we can standardize like longer higher values or something like that. Okay, those things I have already explained in my previous video. You can check that. Okay, so this is how k nearest neighbor works for regression problem. Okay, it basically tries to it basically calculate the average of the nearest nearest neighbors. Okay, nearby values. Okay, that should be similar for my input column. Suppose I have these input columns, it will always look for the similar values of these input columns, and suppose, and it will calculate the, suppose I got some values which are similar to this one, these three. Okay, so it will calculate the average of them. Okay, and it will give my prediction. Okay, so this is how K nearest neighbor works for regression problem by calculating the distance. Okay, so that's all in this video. In the next video, we will see SVM algorithm for classification. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss support vector machine algorithm for classification. So what is support vector machine? Support vector machine is a supervised machine learning algorithm used for classification and sometimes regression also. Okay? Its main goal is to find the best boundary, or we can say hyperplane that separates different classes. For example, spam versus not spam, cat versus dog, fraud versus normal transaction. It basically finds best boundary called hyperplane that separates different classes, like it separates spam not spam by hyperplane, cat versus dog, fraud versus normal transaction. It basically separates these two classes using hyperplane. Okay, for example, real life example, Re- we will have some red balls on one side, blue balls on another side. Okay, then there can be many lines separating them, right? So SVM chooses the line that leaves the maximum distance or margin from both classes. Means the basically distance between these classes and hyperplane must be maximum. Then it will choose that hyperplane. Okay, basically larger margin is equal to better generalization, lower chance of wrong prediction, right? Because see, suppose this is a graph where I have this hyperplane, and these are my two different classes, right? So if there will be highest, means there will be more distance between these two classes by this hyperplane, then it means my classes are classified perfectly, because the distance is far from the hyperplane for both classes. Okay, so it means by the hyperplane, it basically classified the data perfectly. right? So, so this is how SVM works. It creates a hyperplane, separates the classes, and predicts the output, right? So this is how vector machine for classification works. Now, some important terms in SVM. Hyperplane. Hyperplane, a boundary that separates classes, which I have already explained. In 2D plane, it is called line. In 3D plane, in 3D it is called plane. High dimension is hyperplane. Margin. Distance between hyperplane and nearest data points means these are my data points and this is my hyperplane. So margin between the data points and hyperplane, basically distance from the data points to the hyperplane, right? That is called margin. Support vectors, the nearest points to the hyperplane. These points are very important because they decide the position of the boundary, means hyperplane. Without support vectors, hyperplane changes. Okay. So suppose this data point is much closer to hyperplane, then it is support vector. This point is much closer to my hyperplane, so this is support vector, right? So this matters more now. Now, what is kernel? Basically, kernel is something which converts low dimensional data into higher dimensional data. Sorry, space. Okay. So the separation between two different data points, between two different classes, separation of between two different classes, or we can say categories, becomes easier by kernel. Okay. So first, kernel is a linear kernel used for linear data, polynomial for which creates like curved creatures, which is not linear, and RBF for complex non-linear data. Non-linear data plus complex. Okay. Sigmoid looks similar to neural networks. When I will cover deep learning neural networks, then I will cover this also. Okay. So now we will check how we can perform SVM for classification, okay, and how we can use kernels also for linear data, linear, polynomial, if I have some not linear data, means I have some curved features in our between our dependent variable and independent variable, then I will use polynomial kernel RBF when I will have complex or non-linear data, right? So this is the different cases of kernels. Okay. Now this is my data set on which I will perform my SVM classification. Okay. So how we can perform it? First, we will import some required libraries. Import Pandas as PD. Import matplotlib.pyplot as PLT. Import cbon as SNS. Okay. Now I will load my dataset /csv. So this is my data. I will right click, copy path. I will paste it here. I will check my first three rows by checking uh, dot head. So yeah, my data gets loaded and these are my first three rows. Now suppose I will plot a graph to show how my data is looking like. Suppose I will first give some figure size. SNS dot scatter plot x is equal to, I will take CCPA. I will take Y as academic performance, and Q is equal to my placement, right? Placement, okay. Now I will write plt.show. Oh, sorry, I have not given data, as data is equal to, I have loaded my data into data variable, so I'll give that also. So yeah. So this is how my data is looking like, a little bit very complex data, right? Okay. So now I will first divide my data into input and output. I log. I will take my all input columns into my X, means give this means give me all rows, give me all columns, but don't minus one means, but don't give me the last column, which is my output column. And in Y, I will take my output column. That is placement. Sorry, that is my placement. Right now, sorry, I mistake. This is my mistake. I gave one more comma. So uh, my data gets divided into input and output. Now I will basically divide my data set into training and testing. 80% for the training and 20% for the testing. Okay. From sklearn dot model selection import. I will import train test split. Okay. Now, now I will take my all four variables x train, x test, y train, y test is equal to, I will call my train test split. I will give my x and y variable because I have loaded the input columns and output column into x and y. I will give test size is equal to 0.2 and random state is equal to 42. Okay. Now my data gets divided into a train 80% for the training and 20% for the testing because I have given 0.2 as my test size. Now, now I will create my model from sklearn dot svm import svc support vector classifier because I am dealing with classification problem, so that's why I have imported svc. Now suppose I will create an object to call my svc. Now here I have to give kernel. Suppose like this is looking like a complex data. So I'm just giving my kernel as RBF. Here RBF. Here I explained already when we use different kernel. Linear kernels for linear data, polynomial when we will have some curved creatures in my into my graph. Then we will use polynomial kernel and RBF kernel, which we are using for complex and non-linear data. Okay, so and sigmoid for like neural networks. So this is how this is when we use different kernels. Okay, according to our situation. So suppose I am taking RBF as my kernel. Here I'm commenting some kernels for you. Like for linear, you can write linear. Okay, linear. You can write when you will have linear data. Instead of RBF, you will write linear. And if you want to apply polynomial, then you just give to poly. Okay, and the last one, which is sigmoid. You just need to give sigmoid. Okay, now and RBF I'm using. Okay, so these four different kernels are there in SVM, support vector machine algorithm. So yeah, I'm giving RBF. Okay, now suppose I will fit my training data into my model, right? I will train my model by my training data, X train and Y train, right? Right? It gets fitted. Now suppose I will check my accuracy of my model. X test, comma Y test into 100. So this is very low accuracy I'm getting. It only 83.7. But yeah, you you got an idea how we can use SVM algorithm for classification. So this is how we can use SVM algorithm for classification. And here we how we can use different kernels according to our situations in SVM algorithm for classification problem. Okay. So in the next video we will see how we can use SVM classification SVM algorithm for regression problem. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss support vector machine SVM algorithm for regression. Okay. In previous video we saw how we can use support vector machine algorithm for classification. Okay. So first understand what is SVR. SVR stands for support vector regression. It is the regression version of SVM algorithm. Okay. SVR predicts continuous values, not categorical values like cat, dog, okay, uh, red ball, blue ball. Those are categories. It predicts continuous values like house price, salary, temperature, stock price, like that. Okay. So, what is the main idea of SVR? Basically, it fit the best line inside a margin or boundary. I will explain it through a graph. Okay. SVR says small errors are okay, but only focus on points with large errors. The on those points which have large errors, it adds penalty to them. For small errors, it neglect that. Okay, so this is the main concept of SVR and margin. What is margin? Margin, like you can understand it. If prediction error is small, ignore it, or if error is outside the margin, then add penalty to them. Okay, this is what is the concept of SVR, the logic of SVR. Now you can understand by this graph. Here you can see the data points like this. Okay, like this. Okay, these orange dots. These are your data, actual data points, and it drawn a prediction line with respect to those data. Okay, so this is how it tries to predict from those actual data points. Okay, this is how it makes prediction. So we will see how we can use support vector machine for regression. And last thing, kernel. I have already explained what are the kernels in my classification. Basically, kernel which converts low dimensional data into higher dimensional issues. There are four types. Linear kernel used for linear data, polynomial kernel. When we will not have linear data, we will have some curved like shapes in our graph, then we will use polynomial kernel, RVF kernel for complex nonlinear data, and sigmoid we will use it later when we will cover neural networks. Okay, so kernel concept is basically similar to for regression. Okay, so on this data set, I have where I have total experience and certifications as my input column, and my output column is salary. Okay, so we will apply my SVM algorithm for regression on this data set. Okay, so let's see how we can do it. First, I will import some required libraries as np import pandas spd import matplotlib dot pyplot as plt import seaborn as essence. Okay, now I will load my data set pd.read slash csv. This is my salary multi.csv is my data set. I will right click, copy path, paste it here. I will check it first three rows. So yeah, my data gets loaded and these are my first three rows. Okay. Now, suppose I will plot a graph to show how my data is looking like. Fixed size, comma 4, SNS dot scatter plot. Scatter plot, I will give X as my total experience. Total experience. Y, I will give Y for certification. Okay. And I will give my data as my data because in the data variable I have saved the data. I will take Q parameter salary. Okay. Now, sorry, plt dot show. Okay. So this is how my data is looking like. Okay. Now, first I will basically divide my data set into input and output. -1 means I give me all the rows and all columns, but -1 means don't give me the last column, which is my output column. I will take output column into Y. Okay, my data gets divided into input and output. Now, I will divide my data set into training data set and testing data set. Okay. Model selection, import, train test split. Okay. Now, I will take my all four variables x train, y train, sorry, x test, y train, y test is equal to, I will call train test split. Yeah, I will give x and y. I will give test size as 0.2 I want 20% as my testing data and 80% as my training data. So I will give test size equal to 0.2 and I will give random state is equal to 42. Okay. Now I will create my model from sklearn dot svm import SVR because we are dealing with regression problem. For dealing with classification problem, we import SVC. Okay. Now, now suppose I will create an object to call SVR. Okay. Now I will give kernel. I have already explained in my previous video also where I explain SVM algorithm for classification, what kernels are, and in this video I also gave an overview what kernel, what is kernel. Okay. Now, suppose I'm giving my kernel as RBF. There are total four kernels. I will write it here. Linear. Okay. Second one is polynomial. For polynomial, we just write poly. Okay. And third one is your RBF. Fourth one is your sigmoid. Okay. So, so I've already explained how we can use different kernels according to our situations. Okay. For example, if we will have linear data, then we will apply linear polynomial for basically when we will have some curve like features, then we will use polynomial kernel RBF when we will have complex or non-linear data, and sigmoid we will not use this now. When we will cover neural networks, then we will apply sigmoid kernel. Okay. Now these are the four types of kernels. So first, let's suppose I'm taking RBF. Okay. Now I will fit X train and Y train. I'm training the model by my training data. Now suppose I will check my accuracy of the model. X test comma Y test into 100. So this is giving very low accuracy. Okay. RBF. Okay. Let's suppose I will take linear. Okay. So by linear, I am getting 71% accuracy. Okay. Now let's take poly. By poly, we are getting 59 accuracy. So for now, I'm only giving linear because from linear, we are getting some high accuracy, not like high, better than these two kernels accuracy. I'm getting 71% accuracy. So we are getting low accuracy because we have not standardized our values. Okay. So we need to perform standardization. Okay. So I'm not covering standardize in this video. I have already covered how we can perform standardization and why we perform standardization in my previous video where I covered data preparation. You can check that playlist. Okay. So uh, this is how we can use, you got an idea, right? How we can use SVM algorithm for regression problem. Okay. So uh, that's all in this video. And we also like covered how we can use different kernels according to our situations for regression problem also. So that's all in this video. In the next video, we will cover hyperparameter tuning. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss hyperparameter tuning. So what is hyperparameter tuning? First understand what is hyperparameter. Basically finding the best settings for a machine learning model to get maximum performance. These settings are called hyperparameters. And now uh, let me show you what is those settings exactly. Okay, let's suppose I have performed decision tree algorithm for classification in my previous video. So let me show you what is hyperparameters. Okay, so first let me execute all the line of code. Okay, so here you can see when you will click here. Here we have taken max depth is equal to 4. This is also a type of hyperparameter tuning. This is a type of manual tuning. I have chosen max depth is equal to 4 means I only want total depth as 4. I only want my model till the depth 4 in decision tree. Suppose I will click here shift plus tab here. Now you can see the criterion, splitter, max depth, minimum samples split, minimum samples leaf. These are called hyperparameters. Okay, these are called hyperparameters. So, building a good model according to our scenario or situation, we just give values according to our situation or scenario, like in criterion, splitter, or like required things. Okay, these are default values. Okay, so on the basis of our requirement, we choose the values of these hyperparameters. Okay, so that is called hyperparameter tuning. Hyperparameter tuning. So there are three ways of hyperparameter tuning. First one is manual tuning. Manual tuning I have already shown. This is like I have chosen max depth is equal to 4. So this is a kind of manual tuning. I have tuned it manually. Max depth I have chosen 4. Now what are the next two methods? More two methods. Grid search and random search. What grid search do? Basically you give multiple values, then model tries every possible combination and then select and will give you the best combination. Okay. And third one is random search. It will not check on all combinations like grid search. It checks random combinations. Okay. And it will give you a best combination according to the random search. Okay. So now we can do it practically. How we can do these, how we can perform these three methods for hyperparameter tuning. Okay. Now let's take our new file, hyperparameter tuning. And on this dataset, I will perform my all three methods of hyperparameter tuning. Okay. So this is my output column and these two are my input columns, total experience and certifications. And on the basis of these inputs, we are calculating salary. Okay. So first I will import pandas library, import pandas as PD. Okay. Now I will load my data set. Suppose I will take a variable data slash CSV. Okay. So this is my data set salary multi.csv. I will right click, copy path, control V, and I will check my data is loaded or not. Okay, by checking first three rows. Okay, now my data gets loaded. Okay, now I will basically take all the input columns into X and output column into Y variable. Okay, data dot ilog. I'm saying give me all rows and all columns, but don't give me the last column minus one. That is my output column. I will take output column into Y. Data, I will take salary. Okay. Now, my data gets divided into input and output. Now, I will divide my data set into training, 80% for training data and 20% for the testing data. So I will load train test split sklearn dot model selection import train test split. Okay. Now, now I will take my all four variables x train, x test, y train, and y test, right? And I will call my train test split to split my data. I will give my both variables x and y. I will give my test size as 0.2 as I want 20% of total data as my testing data and random state is equal to 42, right? Now my data gets divided into 80% for the training and 20% for the testing. Okay. Now, now let's build a model. Suppose I am taking a decision tree. Okay, for building a model. So I will import decision tree sklearn dot tree import decision tree regression because it is a problem of regression. So I'm importing regression, not classifier. Okay. So now let me give the method one manual tune. I will give a markdown here manual tuning. Okay. I will give a markdown here shift plus enter. Yeah. First one manual tuning. So this is very simple. Let's take an object to call my decision tree classifier. Okay. This is simple. Suppose I'm taking max depth as 5. Max depth as 5. Okay. This is your manual tuning. Okay. Where you are giving the where you are giving some values to your hyperparameters according to your situation. Okay. Basically by yourself. You are giving max depth is equal to 5. This is the kind of manual tuning. Okay. Let's fit dt dot fit our training data x train and y train. Okay. Now it gets fitted. Let's check its accuracy. dt dot score. I will take x test comma y test into 100. So we are getting 89% accuracy. Although we can increase our accuracy by performing standardization also because there is a need to perform standardization on this because you can see salary has many much much higher values than this one. So model will give more priority to the salary column. Okay. So I'm not performing standardization. I've already covered what is standardization and how to perform it. My motive of this video is to basically show you how we can use different methods of hyperparameter tuning. Okay. Now, now let's take second grid. What was the our second method? Grid search, right? Grid search and third one random search. So first we will see grid search. Okay. First let me give a markdown here. Second grid search. Okay. I will choose markdown. I will click shift plus enter. Okay. Now I will import first from sklearn dot model selection, import grid search CV. Okay, CV. And let's import second one also. That is our random search. And I will import it randomized search CV. Okay, let's import this. Yeah, I have imported this. Now let me make a variable, okay, where I will take all like required hyperparameters and all their values. Okay, let me take df is equal to, okay, so first one is our let me see here from here, right? Shift plus tab. Suppose I will take first criterion, okay, criterion. So I am taking criterion, okay, first one, okay, criterion. Now let me see what are the values are available for criterion. Shift plus tab, and here you will see there are four different types of criterion are we can take. Okay, default one is your squared error. So let me take all this. Okay, I will take all this here. Control V. Okay, okay. Now what was our second one? Again, I will go for it. Shift plus tab. Now let's take splitter. Splitter. Okay, as our second hyperparameter. So I will give this, and again I will see what are the values are available for it. Splitter, best and random, and default is your best. Okay, Control C. Okay, sorry. Okay, best and random. And last one, I will suppose I will take max depth. Max depth. Suppose I am taking a range in max depth. Suppose I'm taking a range I in range. Suppose I'm taking 2 to 20. Okay, 2 to 20. I'm taking this range. Okay, now plus enter. Oh, okay. I forgot to put a comma. Okay, yeah. So now let me create an object to call my grid search CV. Grid is equal to, I will call my grid search CV. Yeah. Now, I will first take decision tree regression. Okay. Now, second thing, I will give parameter grid. Parameter grid. Okay. SDF. All these values. Okay. SDF. Okay. Now, I will fit my training data into it. gd.fit xtrain, comma, ytrain. Okay. Yeah, it gets fitted. Sorry, till now it is not get fitted. Yeah, it gets fitted now. Now let me check what are the best parameters it is given. GD dot best parameters params. Okay. Yeah, it is saying your best criterion you can take as poison, poison. Okay, and max depth you can take 4, and splitter will be best. You can take best. Okay, so what we can do, uh, we can give these parameters in our decision tree. Let's take this. Suppose I'm calling it as DT2. Okay, now I'm giving these parameters here. Control C, Control V. Okay, I will remove the, okay, I will remove this. Okay, so it is giving me error here. Let's take this. Let's take equal to. Okay, now it gets fitted. Now let me check the accuracy. Dot score. Sorry, DT2 dot score. Now I will take X test, comma, Y test. So it is giving me 90% accuracy. Okay. First I was getting 89% accuracy. Now I am getting 90% accuracy. Once you will perform standardization, the accuracy will be increased much more. Okay. I'm not performing standardization here. So here you can see my accuracy increased a little bit. Okay. So this is how we can perform grid search. Now let's see how we can perform the third one. That is our random search. Okay, let me give a markdown here. Random search. Okay, that is our third one. Sorry, I will have to give markdown here to highlight this. Yeah, random. Again, I will give third number. Okay, third random search. Now, how we can perform random search CV? Let's take an object to call random search CV, as I have already imported this here, randomized search CV. So I will call this. Okay. Now, now I have to uh, give decision tree regressor. Okay, comma, and parent distribution. I have to give distribution. I have to give my DF, and I have to give an iteration. An iter is equal to let me give 20. Okay. Now, okay, distributions. Okay. Now I will fit rd dot fit x train and y train. Okay, it gets fitted. Now let me check what are the best values of parameters it is given. RD dot best parameters, best params. Okay, okay, yeah. It is saying that splitter we should take best, next depth we should take 5, and criterion should be we should take squared error. Okay, now let me check if it is increasing my accuracy or not. So it is saying to take criterion as squared error, right? So I will take this control V, and it is saying next step we should take 5. Okay, it was saying 4 and it is saying 5 we should take. And splitter is best. It is also saying best. So we are not changing this. So now it gets fitted. Let sorry, I will first create a new variable. Now let me check the accuracy. dt3.score x train, sorry, x test, comma, y test into 100. So it is giving 89% accuracy also. Okay. So here we can see by manual tuning, I got 89% accuracy. By grids using grid search, we got 90% accuracy, and from random search, we are getting 89% accuracy again. So to basically increase the accuracy of obviously we need to perform standardization. So here are these three ways to perform hyperparameter tuning. Okay, to choose the best values for your hyperparameters, like like grid search suggested that you should take criterion as position, max depth as for splitter as best. You should take. Okay, so we implemented that in this. Okay, and 1% accuracy improved. Okay, so this is how three different methods of hyperparameter tuning you can perform. So these are the ways to perform hyperparameter tuning methods. Okay, so that's all in this video. In the next video, we will see cross validation. Okay. So thank you. Hello guys, welcome to the channel. Today we will discuss cross validation. Okay. So what is cross validation? Cross validation is a technique used to check how well our machine learning model will perform on unseen data, whether the model is overfitted, underfitted, or performing well. Is what it does, instead of testing the model only once, cross validation tests it multiple times on different data. It means when we basically create a model of supervised learning, then we just basically split the data into two parts, training and testing, right? So there is one data for training data and there is one data for testing data, but it will it basically splits the training and testing both data into several parts. Okay, so and test that on all the splitted data set. Okay, why do we need cross validation? Because suppose you have 80% training data and 20% for testing data. Then maybe the test data was too easy, maybe it was so difficult. So in that case, accuracy may not represent the real performance, right? So cross validation solves this problem by changing the train test split multiple times. Remember this. It will change the train test split multiple times and taking average performance. Okay. for all splitted data set. Okay, how it is performing on all splitted data set. Okay, so there are some ways of doing cross validation. First one is your k-fold cross validation. What it does, suppose you have 100 records and you have chosen k is equal to 5, then it will split the data set into five equal parts. Okay, so divide 100 by 5 is equal to 20. Okay, so each fold will contain 20 records. Okay, so first one, this is how k-fold cross validation works. Second one, stratified k-fold cross validation. It is used for classification problems. And suppose a data set is your data set is imbalanced. You have 90% data as cats in your output and 5% only for dogs. Okay, then in normal k-fold, it will create bad spread, right? Because you have only 5% of, right? And then stratified k-fold keeps same class proportion in every fold. Every fold means it, suppose it has splitted the data 10 times, then it will basically keep these two categories or these two classes into same proportion, no difference. Okay, so this is how stratified k-fold cross validation works, and leave one out cross validation. Only one data point is used for testing and remaining all data points are used for training. What it means? Suppose I have five records. Okay, one, two, three, four, five. So what it will do in the first iteration, let's say one will be for testing and two, three, four, five remaining four will be for training. Okay, in the second iteration you will have suppose two as your testing data and remaining one, three, four, five will be for training. And leave p out cross validation, in which in this cross validation we will give, suppose p is equal to 1, p is equal to 2 or p is equal to 3. In with respect to that p is equal to 2 3, suppose we have given 2, then it will take two uh, two testing data from each iteration. Suppose I have 10 I have five records and one, two, three, four, five, and I have given p is equal to 2. Then maybe it's it will take 1 2 for training. Sorry, 1 2 for testing and remaining 3 4 5 for training in the first iteration. In the second iteration, it will take suppose 1 and 3. Then you will have 2, 4, 5 as your training data. Okay, this is how leap payout cross validation about. We will see how we can use all these cross validation techniques practically. Okay, so suppose I have this data set. So I have CGP as my input column and package I have as my output column. Okay, so basically it is a regression data. So uh, I have second one stratified k-fold cross validation. It is used for classification problems, so it will not work on this data, but I will show you the syntax for this validation technique also. Okay, so let's see how we can do it practically. Okay, first I will import my pandas library as PD. Okay, now I will load my data set. Let's say I have data set. Okay, Uh, this is my data set placement.csv. I will right click, copy path, control V. Now I will give data.head. Now my data gets loaded and these are my first three rows. Okay. So basically uh first I will make this data smaller because it will have multiple records And when we will perform leave one out, leave P out, then it will work very slowly because I have multiple records. So suppose I will create a new variable. In this, I will take only starting, I will take only starting 10 rows. Okay. Okay. And suppose I will basically split the data set into input and output. Basically, I will take input data into my X new and my output data package into Y new. Okay. Suppose uh, data I will take as I have only one input column and one output column. Okay. And I will take Y new is equal to data package. Okay. Now my data gets split into two parts. Okay. Now I will import all four methods. Okay. Scalar dot model selection import. First, I will import leave one out. Leave one out. Okay. Second one, let's say I will take leave P out. Third one, I will suppose take K fold. And last one, let's say I will take static. Although it will not work on this data set because this is the problem of regression and this stratified k-fold only works for classification. But although I will show you the syntax for this also. Okay. Stratified stratified k-fold. K-fold. Okay. Okay. Here is the spelling sticker. Capital O. Okay. I will take I will copy paste from here. Okay. Now I've imported all this. Now let's take first one. Leave one out. Let me make an object for calling leave one out. I will call leave one out. Okay. Now I will I will give an for loop for I will take train and test in LO dot split. I will pass my X new and Y new. In my X new, there is my input column, and in Y new, there is my output column. Okay. Now I will print my train and test. to train test is not okay, sorry. Yeah, you can see it. Okay, this is how it is splitted my data. Okay, let's see. First one, my zero. You will not gonna find here zero. Here I have one. You will not gonna find one here. One is for training and remaining all for testing. Zero. Zero here you will not find. One you will not find here. Two you will not find here. Basically here you can see zero is for testing and remaining all these values are for basically training. This is for testing and these are all are for training. This is how it is splitted. Okay, one by one. Here you can see till 30, all the values it has taken one by one. Okay, so uh, I will not print it. Okay, suppose I will I will keep this as it is. Okay, now I will remove this. Okay, now first one I perform leave one out. Now how to perform leave p out? Let's take an object LP to call leave p out. Okay. Now here you have to give p is equal to 2 or, or whatever value you want to give. P is equal to 2, 3, 4, anything. Okay. So again make an I will make a for loop for train test in LP dot split x new comma y new. Okay. Same I will show you by printing it. Print train and test. Sorry. Again I gave slash. Okay. Let's see. First one here you can see 0, 1. It has taken as for testing and remaining all for training. See, you in this array, you will not gonna find 0 and 1 because 0 and 1 it has taken for testing. Remaining all are for training purpose. Okay. Here you can see 0, 2. 0 2 will you will not gonna find here because it has taken 0 2 for training testing here and these are for training. So this is how leave p out works. Okay. Suppose I will not print it. Okay. Now third one. Let's take K4. Suppose I will make an object K. Okay. I will call my K4. Okay. Now let's take an split. Mid means convert my data into let's take 5. Divide my data set into 5 equal parts. Okay. I will copy this simply. Okay. I will basically just put KF here. Sorry, I will have to print. Yeah, here you can see it has divided your data set into 5 equal parts, and these are 0, 1, 2, 3, 4, 5 till 39. It has taken for testing, and all these are for training. And then after 39, it has taken 40 to 79 for testing, remaining all for training. Okay, so this is how it is splitted my data into 5 equal parts, and it has taken uh, testing data by itself and training data by itself. Okay, 0 to 39 for the first iteration, and 40 to 79 for the second, 80 to 119 for the third, and 120 to 159 for fourth, and 198 till 198 for the last one. Okay, so this is how k-fold works. Okay, although stratified will not work here because I have regression data and it only works for classification. But although I am showing you the syntax, it will have the same syntax. I will call this. You will have to again give an split. Let's take is equal and split is equal to 5. Now just copy. It will throw an error. Okay, it will throw an error because give here escape. It will throw an error because this is a problem of regression and we are applying stratified k-fold for regression. Okay, this will not work. This will, okay, I have done something wrong here. It is basically working here, but although we generally use stratified k-fold for classification. Okay, it is basically working by thinking it as a classification problem, but this is not my classification problem. This is my regression problem. Okay, although I have shown you how we can perform all the cross validation techniques, these 4 techniques, how we can perform. Okay, so that's all in this video.